Good morning, everybody. Welcome to this core flow-based introduction workshop on the capacity allocation and calculation for the core capacity calculation region. I'm Rut Otter. I work for Tenet, one of the participating TSOs, and I will guide you through this workshop together with Gert-Jan Muitgeert.
Yeah, my name is Gert-Jan Muitgeert, working for Magnus and role as project manager of core flow-based DHET as a convener, both involved in the TSO project and joint project.
The other speakers are Michael Nemi. Michael, could you introduce yourself?
Good morning. My name is Michael Nemi. I work as a flow-based expert in CHEPS, which is a Czech Republic TSO, and I will guide you through the details of the core capacity calculation methodology.
And next speaker is Adèle Roy. Adèle, could you introduce yourself?
Hello, I'm Adèle. I worked for IPEXPOT, which is an MO participating to the core project, and I will guide you through the capacity allocation process.
And I also want to introduce you already to Marius Schade, who will do something on transparency in the afternoon. Marius, could you introduce yourself?
Yes, of course. Hello, good morning, everyone. I'm Marius Schade. I'm working for 50 Hertz, and indeed we will together this afternoon go through KPIs in the transparency framework.
Okay, then I switch back to the presentation where we have an overview of the speakers. And also go further to the sort of rules, the housekeeping rules of today. We have a large audience today, so we cannot have real interaction with discussions and so on. So we arranged for a Q&A where you can submit your questions through the web interface. And in the Q&A sessions, Gert-Jan and I will pick out some of the questions and will post those to the different speakers. We also have an interaction through Mentimeter, where we will ask you some questions and to see whether we can get some feedback or maybe tune something. And another thing is that, this whole session will be recorded and be published on the ENTSO-E website in the end, so it can be viewed again. Then I go to the program of today. Maybe it's good to mention that this is all for the preparation of the flow-based capacity calculation allocation that we will introduce next year in the core capacity calculation region. On Friday, there was a message that this flow-based go-live will be delayed to Q2 2022. This is not a subject for today. This will be because today we want to focus on the content, but next week there is a core consultative group where this will be elaborated further. So today we will stick to the content of flow-based calculation and allocation. And the first part of that will be a short introduction with an overview of the different topics. Then we have, at the later part of the morning, we have a more in-depth explanation about capacity calculation. By the way, we in preparation of this workshop, we investigated what would be the main topics, and in-depth explanation of capacity calculation was one of them. The afternoon session will be dedicated to all about transparency, about publication, and about how to use the publication tool and where you can find the different data. Then maybe it's also good, we've introduced ourselves, that we introduce you a bit so that everybody can see what kind of audience we have. And I give the word to Gert-Jan for that, because we're going to use the Mentimeter. It's also immediately a test to see whether this works.
So if you can show the slide with the information on the Mentimeter, so you can go to the website menti.com, or you can insert the code, or you can scan actually the QR code, and then you can access this as well. We will give you some time to get into this Mentimeter, and then we have a few questions. So indeed, like explained by Ruud, we can know also what kind of people we have in the webinar today. So let's take some time so that you can all access this. So normally I will also be able to see if people can already insert the questions. Hopefully this is working well. Luckily, indeed, I was already warned for this. That takes some time. So we already see some reactions. So for now, there's a lot of people in the energy trading. They are the quickest ones to react. Also, regulatory authorities are in there. Energy production, and people from the related to the energy transmission. So we see a nice distribution of all kinds of participants. So already, so we see a nice distribution. Indeed, a lot of people energy transmission. Still, a lot of energy traders. Maybe we can go to the next question slowly. We see a bit the distribution. Let's see. Another question is, how many years of experience do you have in the energy business? That's also a question. So we know a little bit where you are coming from, and also the experience. It's good to know. Well, then we immediately see popping up the 10 years plus experience. So a lot of people that have experience. Hopefully, we are still able to present you something new, of course. But I'm sure that we have the experts that can bring a lot. And also, we see a lot of people between 2 and 5 years. So that's good to see. Also here, a lot of distribution. And as said, it's I think we have quite some interesting material, even for the people also with a lot of experience. So let's continue. I think we have one last question. Also important, of course, why do you participate in today's webinar? For us, it's of course also interesting to know a little bit. What is your take? What is your interest? Of course, to see. Curious about the flow-based. We see updates. So responses are dripping in. Price forecast. I can imagine this also seeing the traders. Energy trading updates. Knowledge, learn. Price forecast again, indeed. Learning about flow-based. Well, I think you will be able to do so after today's session, so that will be okay. University education. That's also nice. News about flow-based. Market modeling. So good to see a lot of reactions. So I see a lot about getting to know more the knowledge part, but also the information on forecasting. So both of course are probably interlinked. Knowing a little bit more can maybe help you to do your own forecasting. So please continue with your additions. For us, it's always interesting also after the meeting to know a little bit what is your interest also for future meetings. So thanks a lot. I think we
Yeah, let's
should continue.
resume then with the content part of the program, and therefore I will guide you through some basics of what we are working on in core capacity calculation region. Maybe it's good to mention, of course, this is an introduction workshop, so we assume that you actually are quite new to the flow-based methodology. And this workshop is especially aimed for that. But obviously, there's always things to learn, especially, I think, maybe in the afternoon session, also on the transparency and the publications. Yeah, let's bring up a first slide on the introduction. And the first question there, yeah, I see it now. The first question there is why actually are we doing this? And there are several reasons, and maybe the most important one that is that flow-based will enhance the ability to make this transition to a carbon-free energy system. It is vital that we use the system to the maximum to allow for weather-dependent generation. But also the fact that generation might be not as close to load as it was before. And that also brings us directly then to the system reasons. Obviously, the better use of the system, the better coordination enhances security of supply, enhances operational security. But obviously, to make it all work, to make it efficient, we need a market. And therefore, these improvements, this closer cooperation, this regional optimization enhances also market functioning. It increases competition and it increases the size of the market. So that are the main reasons actually for doing this. Yeah, some basics about the market we are working in now. We are working in a zonal market, and this zonal market has the things that within a zone you can trade independent from the location you're in. But cross-zonal, there are limitations in the grid that are taken care of, and the market has to include that in their system. That means that we need systems for that, and that we need allocation. And the whole point about this allocation is that we want to do it non-discriminatory, and therefore you need auction type of allocation procedures to let that happen. Therefore, we need exchanges to do that. This is the that's so there basically in this this work on congestion management, what we are doing, we have two types of congestion management. First of all is inside a zone where we socialize basically the cost of redispatch. So in the end with redispatch we arrange for that the price in the zone stays the same. For the cross-border, the cross-zonal allocation, we use an auction to allocate the capacity on a non-discriminatory way. And there are basically two steps in this. And first, it is the capacity calculation, where we calculate the safe domain for the release of capacity to the market. And the other is the allocation. That is the task of the exchanges, where with taking into account the economics, allocate the capacity to the parties that want it most. This is non-discriminatory, it's market-based, and it is transparent. The day-ahead allocation we are talking about now is sort of the easy part. gives us time to calculate. It's also reasonably far from real time. So this is the first step we are doing now. But there's more to come based on the market codes and the operational codes that have been defined in a European context. So we will also do similar things for the long-term allocation, for intraday, for balancing, and also for the coordination of a redispatch on a regional basis. Yeah, and this is the organization for that. We had some doubts whether we show this to you because it might be a bit superfluous, but it's good to see how what type of organization is behind what we are doing. And the core of the work is done by the core capacity calculation region, that's in the black box, together with the core joint project, that's in the green box. The black box is basically the capacity calculation, and the green box takes it in his system with the capacity allocation. So in the green box, it's a cooperation of NEMOs, the exchanges, and the TSOs. The black box are basically the TSOs. And in that black box, it's good to mention that the TSO organize themselves with each other in certain service providers. Obviously, as a market participant, you know JAO perhaps, but also TSCnet, Coreso, which are regional security coordinators, and further different IT vendors, of course. But let me elaborate a bit on the RSCs and TSCnet, because these are typically TSO arranged corporations that provide important services, coordinational services to the core project. So first, the RSCs. Here you have a map with the RSCs in Europe, and for core, Coreso and TSCnet are relevant. Coreso and the RSCs typically do security analysis, capacity calculation, outage coordination, adequacy forecast, and a common grid model merging. For the capacity calculation, especially the last one is of course an important part. Then we have JAO, the Joint Allocation Office for Europe. Actually, it's far larger than the core region only. But JAO also provides services for the core capacity calculation, especially on post-coupling aspects, the congestion income distribution, the data publication, and market messages for the core. So this is basically an outline of background. And with this, I give the work to Michael, who does a first introduction on the core capacity calculation, which will be elaborated further then in the second part of this morning. Michael, could I switch you?
So, good morning once again. And as it was mentioned by Ruth, before deep diving into a detailed description of the core capacity calculation methodology, which is on the agenda from 10:30, I would like to firstly introduce you the basic principles of capacity calculation in general. And we can understand this as a little bit unification of the knowledge of different participants in this workshop. As we have seen in our voting, there is quite difference in the experience of the participants. So let's get started. So first of all, we should answer ourselves a biggest and most crucial question, and that's why we are talking about capacity calculation in general. And the reason is the physics and the physical nature of the power grid. Any electricity that is generated in the power units needs to be transferred to the end consumers. And this is done using power lines and other equipment in the power grid. And of course, all these lines and equipment have some physical limitations. They can be very easily overloaded. And therefore, it is necessary to set some values how much electricity can be transmitted in the network. And for this reason, we calculate the cross-zonal capacity. And anyone who would like to buy or sell electricity cross-zonal have to buy this cross-zonal capacity before doing so. Within bidding zones, on the other hand, we assume that the capacity is unlimited. This is due to the fact, of course, this is not completely true, but because there are still some physical elements in the network, but this is due to the fact that within the bidding zones, the power grid is much more denser than between the bidding zones. And this is caused by historical reasons. Okay, and so the cross-zonal capacity is calculated by TSOs or in some bigger cooperation, as it is the case in the core region. And then they are offered to the market participants. And the capacity is calculated in many time frames. So it's the long-term capacity, which are the yearly and monthly products. Then it's the day-ahead capacity, which we will be talking about today in the whole presentation. And then, of course, also the intraday capacity. And there are basically two types of cross-zonal capacity calculation, or two principles how to calculate the cross-zonal capacity. It's the net transfer capacity approach and the flow-based approach. And now I would like to talk and explain to you these two basic principles and show the differences between them. And it will probably show you why in the core region we decided that the flow-based approach is the way forward. Net transmission capacity, also called in short NTC, is a proven concept how to determine the cross-zonal capacity. In its original form, it is performed individually by every TSO. And the result of such calculation is one value per bidding zone border. Or actually, there are two values, one for import direction and one for export direction. The calculation, as I have already said, is performed by every TSO separately. So every TSO is following their national methodology how to calculate the cross-zonal capacity. Also, TSO can only use the input data which are available to them and use some assumptions that they have for the calculation. As a result, it can happen that the resulting value, the resulting NTC capacity for one border can be different than the capacity calculated by the neighbor. So here I present to you an example, a short example of the Central Europe region and capacity calculation between the Czech Republic and Poland. And if we would look at the table, then in a first row, we would see the values which were calculated by the Czech TSO. So Czech TSO calculated 1,000 megawatts for export direction and 1,000 megawatts for import direction. But Polish TSO, because they had different input data, little bit different methodology, different assumption, ended up with different values for the same border, which were in this case, let's say 2,000 megawatts and 700 megawatts in an export direction. So, and what to do in such a situation? In this case, we apply a harmonization principle. So to be sure that the offered capacity to the market is secure from the perspective of operational security, we take the minimum of the two values at the border. This is actually one of the disadvantages of the NTC approach, because if in an ideal world, both TSOs should have the same input data and same information available, and therefore they should end up with the same values. But somehow the values were different. Another disadvantage of the NTC approach is that when TSO is calculating NTC value for multiple borders, TSO has to end up with one value for every border, which is a fixed value which is offered to the market. But in the real world, in the physical nature of the grid, it is very common in the mesh grids, for example, in the Central European region or in the core region, that the borders of one bidding zone are strongly connected and dependent on each other. So probably exchanges from Czech Republic to Poland are using also some internal lines in the Czech Republic, or there are transit flows. So so transaction from Czech Republic to Poland goes also partly through Germany or through Slovakia. And this needs to be somehow taken into account when calculating the NTC value. But at the end, there are just one value offered to the market, which is fixed. And it cannot anyhow reflect the way the market participants will be interested in the capacities. So in the end, for example, no one is interested in trading from Czech Republic to Poland. And if it's the case, then probably there is no need to offer capacity in that direction. And more capacity could be offered to the direction from Czech Republic to Slovakia, which is in that particular hour a required or requested direction. But this cannot be really reflected in the NTC calculation, because in the NTC calculation, some values are calculated based on a prediction of the situation and on the market, but then they are already fixed. So this is a disadvantage of this approach. What are the inputs for the NTC capacity calculation? It's definitely the grid model. So a model of a grid and the situation in it. So what are the loads? What are the generations? So how much electricity is produced and how much is consumed, and where exactly in the network? How the grid is connected. So if there are some planned outages, if there's some maintenance ongoing on some power lines, this is everything included in the grid model. There is also a prediction of the status of the other countries' grid, so that we can take into account some loop flows and transit flows from the different countries. And then using this grid model, the capacity is calculated. And we can, if we simplify the process, we can just say that it's an iterative process when we increase net position, which means the amount of electricity that's exported from one country, and decrease or increase consumption in the second country. So on an example of Czech Republic and Poland, let's assume that the Czech Republic will increase production and Poland will increase consumption. And we will do this step by step as long as there is no security constraint breached. And when there is a breach, then we have the final transmission capacity obtained for one border. We also apply the N-1 criterion, which says that the offered capacity needs to be feasible even in case that there is an unplanned outage of any element in the network. The capacity which is actually calculated from the process is somehow referred to as a total transmission capacity, TTC, as can be seen on the right side of the slide. And from this value, we still have to subtract some security margin called transmission reliability margin. This reflects the fact that the capacity calculation is performed before the day of delivery using just a prediction data, and there are a lot of uncertainties in the calculation. And this is reflected by applying some reliability margin. Then the resulting value are the available transmission capacities. Then there is a second and more advanced approach, the flow-based capacity calculation. Its main feature is that its calculation is performed centrally using some coordinated and harmonized rules. The basic difference in the results is that there is not one value per bidding zone border, but the result is a list of critical network elements, which we can understand as relevant elements for cross-zonal trading. And for each and every element, there is available capacity for commercial trading, which we call RAM value, remaining available margin. And then there is also a matrix of PTDF coefficients. These coefficients describes sensitivity of those elements to the cross-zonal trading. The shortened PTDF stands for power transfer distribution factors. On an example of the Central European region, we can see that there could be multiple connects involved in the flow-based computation. In the table, we see how would the results of a flow-based computation look like. So there would be a list of critical network elements. So let's say critical network element A, B, and C. For each of them, there is a available transmission capacity called RAM, 1000 megawatts, 2800. And we would get a matrix of PTDF coefficients. I put here just two columns of such a matrix, but the matrix would in general contain all possible combinations of tradings. And how to read actually these results. So let's assume that we would be interested in a transaction of 1 megawatt between the Czech Republic and Poland. And we would be wondering, is it possible to perform this transaction? In NTC world, it would be really easy because we would simply compare the transaction with the NTC value for that border. But it would actually not really reflect the way how the physical flow would go through the power grid. But here we have the PTDS and RAM, and this will help us a lot. So the PTDS describe the sensitivity. So if we multiply the sensitivity with the transaction we are interested in, we will find out what is the flow induced by that transaction on the elements. So in other words, the PTDS between Czech Republic and Poland for element A says that 60% of the transaction between Czech Republic and Poland actually goes through the element A. And it actually makes sense because it's a line which is directly connecting those two countries. For element B, there is 15% of the transaction between Czech Republic and Poland going through element B, which is actually element between Czech Republic and Germany. So there is a transit flow through Germany to Poland. And so if we are interested if a transaction of 1 megawatt between Czech Republic and Poland is possible, we'll simply multiply 1 megawatt with the PTDS. And if the resulting flow is smaller than the RAM on these connects, this transaction can be done and can be utilized. So that's how to read the PTDS and RAM and the flow-based results. This also very well shows that the flow-based results really reflect the physical nature of the grid and the interconnection of the different borders. So if we would, in other words, by trading, for example, from Czech Republic to Poland, we will also load a lot of other critical network elements in the network, which is really the way how it works in the real life. The main inputs for the capacity flow-based capacity calculation are the individual grid models, which are provided by all TSOs of the corporation. And these grid models already include best prediction for the period of time for which we calculate the capacities. In the first step of the calculation, these individual grid models are merged in a common grid model, which is then used for the capacity calculation. Next, very important input from TSOs is the list of the critical network elements and contingencies associated to them. So what does it actually mean, the list of critical network elements? Those are the elements which we are interested in, for which we would like the RAMs and PTDFs to be calculated in the flow-based capacity calculation process. And contingencies are nothing else than the unplanned outages, which are associated to those network elements. In other words, it's the N-1 criterion. So any element can be defined as a critical network, any element which is relevant for the cross-border trade can be defined as a critical network element. And then it can be defined in just the state, let's say end state, which means the state which is in the grid model, or it can be defined also with some contingency associated. The PTDFs are then a result of an analysis of the situation in the grid model. So the grid model consists prediction of a generation and load, also the connection between the nodes in the network, and for every line there are physical parameters such as reactance and subsistence. And using these values, the PTDFs are calculated. The RAM is calculated, on the other hand, using an equation which I would like to demonstrate on the right side of the slide. So we use the thermal capacity of the electrical branch, so of the power line, let's say. And the thermal capacity is really the physical limitation of the element, how much flow, how big flow it can handle. And from this value, we subtract the internal flows and loop flows, as well as the forecasted flows, which are coming from non-core exchanges. These flows are, I would say, implicitly in the network and can be limited in a very complicated way. And we call these F0 core. Then we also subtract some reliability margin, similarly to the Ntc approach. This is due to the case, due to the fact that we are still using some prediction data. Of course, the prediction in the flow-based approach is much better than in the Ntc world, but still there is some possibility that our predictions are not correct. So we have to subtract that from the thermal capacity as well. And then the remaining portion, which will be there, is already the remaining available margin, the RAM value. Yeah, so this is just the real physical approach how to calculate the RAM. In the real world, or in the capacity calculation methodology, there are then some extra steps as a minimum 70% requirement, as you are probably aware of, coming from the winter package legislation, which is then applied to make sure that the RAM is big enough. But this will be handled, I mean, later in the presentation. Yes. So at this point, I would like to present to you a graphical representation of the cross-zonal capacities, the so-called domains. And the reason to do this is that we will use these domains later on, and it's also a very nice representation of different steps of the flow-based capacity calculation process. From these domains, we will also immediately see what's the difference between the flow-based and Ntc approach. So let's start with a 2D example. Let's assume that there is a space in which we have two axes, the vertical and horizontal one. The horizontal axis, let's say S represents a transaction between bidding zone A and B, and the vertical axis represents a transaction between bidding zones A and C. Then in an Ntc example, which is on the left side of the screen, we can see the Ntc domain. This is created by plotting the Ntc limitation. So for example, transactions between bidding zone A and B are limited by the import and export limitations. And those limitations are here plotted as vertical lines, which are just limiting import and export. In a very similar way, there are limitations for import and export in direction from A to C, which are the horizontal line. One line for import limitation and one for export limitation. And those four limitations creates a rectangle. And this rectangle is the Ntc domain. So any transaction between bidding zones A, B, and C is possible only if it lies within this rectangle. And on this example, we can very easily show the disadvantage of Ntc approach, and that's the independence of the borders and the fixed value of the limitation. For example, assume the point A on the axis from A to B. In this point, A is exporting maximum to bidding zone B. So there is no more electricity, or there is not allowed to export more electricity due to the Ntc export limitation. But at the same time, there is no export from country A to country C. But regardless of that fact, no more electricity can be transmitted from A to B. In the real world, this would probably not be the case because the real physical limitations are based on some lines which are probably shared between the borders. And so by granting the capacity for direction from A to C, we have probably or could have not provided enough capacity for direction A to B, which is the desired direction in the end. But no one knew that at the time of capacity calculation. In the flow-based domain, however, which is on the right side of the slide, this problem should not occur because the flow-based domain really represents the physical nature of the network. Now the blue lines are not some artificial limitations, one for import and export direction, but every blue line, if we simplify it, represents one critical network element. And the distance of the line from the origin is the RAM value, and the incline of the line is the PTDF. And so when we would look at the point A again, then at that point, it is not possible to export more from bidding zone A to bidding zone B on the condition that there are no exchanges between bidding zone A and C. But probably it would be possible, as we can see here in the flow-based domain, to export more from bidding zone A to bidding zone B if we would start importing electricity from bidding zone C to bidding zone A. In other words, the red point would move a little bit lower, and then it would be possible to move it right, into the right corner. And this is actually the fact that by start importing from country C to country A, some element would be unloaded a bit, and this spare capacity, spare RAM, could be used for the direction from A to B. And this is the biggest advantage of the flow-based capacity calculation approach. Of course, what was presented here is just a 2D example using transaction between 3 bidding zones. But in the core capacity calculation region, there are actually 12 bidding zones, plus 2 virtual bidding zones for the Allegro DC cable between Belgium and Germany. And so the domain, the correct domain in the core capacity calculation is actually a 12-dimensional one. But for simplification, of course, the 2D example is very good. So now I would like to finalize this introductory presentation with a short summary of the 2 approaches, of the NTC capacity calculation approach and the flow-based capacity calculation approach. So the biggest difference, which is obvious, is the way how the results are represented. So in the NTC capacity calculation, there is just one value per bidding zone border, one for import and one for export direction. In the flow-based world, on the other hand, the result is a list of critical network elements with associated contingencies. And for every critical network element, there is a remaining available margin, which could be used for commercial exchanges, and a matrix of PTDS, so the sensitivity of the trading. Flow-based capacity calculation has to be always performed in a coordinated manner in some capacity calculation region. NTC approach, on the other hand, in its original variation, is performed individually, and the coordination is then performed by harmonizing the results on the borders. Of course, I must admit that then there is also the coordinated NTC approach, which introduces coordination also to the NTC capacity calculation, and by doing so, it tries to get rid of some of its disadvantages. So biggest disadvantages of the NTC capacity calculation approach is the fact that the final NTC's values are fixed and cannot be then changed based on the real needs of the market participants. And the fixed values are independent. There is also a limited representation of the physical flows due to the availability of the input data. The pros of this approach, on the other hand, are following. Firstly, this approach is quite simple and proven, so it has been used for many years. There is also this coordinated NTC approach, which firstly solved the issue with the coordination, and so getting better input data. And if it is used in a region with low dependency between the borders, then we will also get rid of the second con, which is the independence of the values. Flow-based capacity calculation, on the other hand, has multiple pros. First of all, there are common inputs and rules for calculating the capacity. This is really good because there is a huge transparency for the capacity calculation. I'm sorry. There is, due to having good information, there is also a good representation of the physical flows in the network. The constraints, as we have seen, are linked among each others using the PTDFs, which allows us to do a better and more flexible utilization of the capacities during the market coupling and the capacity allocation. The disadvantage of the whole process is that the process is much more complex to perform. Then there is a last example I would like to provide to you, which also describes the relation between the flow base and NTC capacity. If we would compare the flow base and NTC domain, as we can see them plotted in one graph on this example below, we see that if the flow-based domain really represents the physical nature of the grid, then setting up some fixed values, some fixed limitation for import and export direction, we have to, in other words, set up a rectangle which lies inside the flow-based domain. And this rectangle will always be smaller than the flow-based domain. And in other words, NTC capacities will be smaller than the flow-based domain. So there is not just the issue with the flexibility, but also with the size. So that's the end of the first presentation, and now it's time for your question.
Thank you very much, Michael. We don't see many questions now, so actually I propose to do Adèle's presentation on capacity allocation first now, and then we can compile the questions about the introduction. Please, participants, if you have any questions, please submit them in the interface so we can compile them. But now let's start with Adèle with the presentation on capacity allocation. Adèle, the word is to you.
Thank you. So on my side, I will present to you the capacity allocation processes, and I'll try to highlight the difference between NTC and flow-based. So first, let's give a little bit of context. Today, day-ahead coupling is organized within the single day-ahead coupling organization, or SDAC, which is composed of 47 parties that you can see on the map, and which aims to create a single pan-European cross-zonal day-ahead electricity market. Those 47 parties are working together to allocate cross-border transmission capacity efficiently by coupling the different electricity markets from the different regions through a common algorithm. They take into account the cross-border transmission constraints, and they try to maximize the social welfare. What is CORE within this organization? CORE is a project for which we try to implement a flow-based day-ahead market coupling across the whole core capacity calculation region, or CCR. It's within the framework of the DAC. And you can see here in red the different countries participating to CORE. There is a small problem in the slide, that is Denmark is not within CORE, but is in red. So forget Denmark. Today, the flow-based market coupling is deployed across the Central Western Europe, so it's the deep red countries, except Denmark. And tomorrow, with the CORE project, you will have all the borders of the core capacity calculation region coupled based on a flow-based capacity calculation methodology. So basically, we are adding the lighter red countries to the entire map, and we will have a single methodology for capacity calculation and allocation. So, flow-based methodology for capacity allocation, what does it change? Basically, the main change of flow-based allocation mechanism is that it will maximize the welfare of exchanges in and between bidding zones. As Michael just showed, it will take into account the limitation imposed by the critical network of the transmission system and the outage condition. But basically, what will it mean for you is that you will be able to allocate more capacity than in the current NTC methodology. So you can see on the right picture a graphic example of that, a graphic representation. If you have, as a result of the coupling, the market clearing point A, you have no difference between flow-based and ATC and NTC allocation methodology because the point A is within both domains. If you take as an example the point B as market clearing point, you can see that it is outside the NTC domain. So basically, while using the flow-based methodology, you will have a higher capacity allocated than with the NTC methodology. I won't enter into the detail of why, because Michael already did successfully, so I won't repeat myself. But what you have to know is that the output of the flow-based market coupling won't change. It will still be the optimization of the set of zonal net position and the corresponding market clearing price. And the calculation won't change. It's still a combination of which maximizes the social welfare, for which social welfare is the production surplus plus the consumer surplus and the congestion rate. What will change is that the flow is linked directly to how the flow-based domain is calculated. Because it is defined by a set of constraints, each edge is basically a critical limiting element, as Michael said, and represented, any change of net position is represented by the PTDF matrix. So for capacity allocation within flow-based domain, the physical flow for each line within the allocation is always lower than the commercial available capacity of RAM. You have here the equation that is used for the allocation in the flow-based methodology. So the sum of PTDF times net position is inferior or equal to the RAM. You still have in flow-based allocation methodology, euphemia, the algorithm calculation that uses a heuristic approach. Because you have a lot of inputs to the equation, it's impossible to determine the optimal solution. And so the algorithm has 17 minutes to find the best solution. This doesn't change. Basically, what's changed for flow-based methodology is that the capacity allocated to the market will be maximized. Having said that, what are the changes to the processes for allocating capacities? Basically, the normal day process won't change much. So, a little bit of reminder. What is the normal day process? Normal day is described within normal day procedures that are describing all the action to perform a normal day of coupling in the clear weather scenarios. They are within 4 different procedures. The cross-zonal capacity submission and allocation constraints. This one will be impacted by flow-based because basically the cross-zonal capacities will change within the flow-based calculation methodology. You have then the 3 others, the final confirmation of results, the market coupling result and schedule exchange transfer, and the trading confirmation and schedule exchanges notification that won't be impacted so much by flow-based. So those procedures will exist now within the core region. You will have both DAC procedures and core procedures. Associated to that, you always have procedures used by NIMO only, which aims to represent NIMO only processes. And I have a note that all the shipping related activities are still not included in the DAC procedures and won't be in the core and will be addressed locally. How is the normal day process? you have different phases and different timings. So let's zoom to the phases. First, the pre-coupling. Pre-coupling phase represent the fact that that all NIMOs will first verify their system to be sure that they use the same parameters and configure accordingly. TSOs during the pre-coupling phase will submit the cross-zonal capacities and allocation constraints. So basically for that, the inputs will change, as I said. You can see here the timings, it's around 9:30. Then you will have, still in the pre-coupling, the network data and market orders sent by NIMOs to the market coupling systems. So here you can see that the closure of the order books is around 12, and then the NIMOs will send all those inputs data to the coupling systems. Second, we go to the coupling phase. So here you have the result calculation processes. Results are price and flows. Then the results are shared and received among NIMOs. You have preliminary confirmation or the first round of validation by NIMOs. Those preliminary confirmation results are published. And then you have the final confirmation or second and last run of validation, mostly done by TSOs to ensure that flows and are not exceeding capacities. So in terms of timings, you see that all those phases happen between 12 and 12:45, to which you have the publication of preliminary results, and then the publication of final results is at 12:57. Lastly, you go to the post-coupling phase. Here you have NIMOs transferring the final market coupling result and schedule exchanges to the post-coupling systems. And you have then NIMOs providing the local and cross-border trace to CCP and or cross-border shipper entities. The result, you share information, everyone shares information on the timing of the processes and store it for further analysis. And in the post-coupling phase, you also have the reporting and archiving coupling activities. In terms of timing, the post-coupling, including nomination activities, are done between 1 and 2. And the nomination deadline towards TSOs is done at 2:30. All the reporting activities can be done afterwards, so they are not here on the graphs. So for the normal day process, not a lot of impact of the core allocation methodology, except that basically the input will change. All the timing will stay the same, and the different steps will also stay the same. Let's go then to the partial decoupling of SDAC and full decoupling of SDAC, so-called fallback procedures. So little reminder again about the fallback procedures. They are triggered when the market coupling result cannot be given in due time, and an incident committee is used for normal backup or special procedures. So when you have an issue in normal backup or special procedures, you will go to fallback procedure if the market coupling results are not given in time. They can be split in two parts. First, the preparation of the decoupling. So you have here the incident management procedure where you will open an incident. And then you have the effective decoupling of the relevant interconnectors from the market coupling process. Here you have the description of the capacities allocated via the explicit auction and the reopening of order books locally, and a new local price calculation is launched. Those into two procedures, the fallback decoupling or the partial decoupling, depending on the case you are in. In case the issue is solved, and so you don't need no more the incident committee and the full decoupling or partial decoupling, you will come back to the previous procedure you were in, normal, backup, or special. So what are the two types of decoupling? First, decoupling. For every decoupling situation, you have to understand that the single day ahead coupling core principle is to ensure that as many bidding areas or interconnector as possible must remain coupled. Therefore, you will always try to have first a partial decoupling, and if really the situation cannot be solved, or if the incident is more important, you will have a full decoupling. So partial decoupling is triggered at 12:45 if one or more operational NEMOs are unable to participate in the stack coupling. I will show you here the timing because it's a little bit more understandable. So basically, if NEMOs cannot receive the CZCs or the market coupling system cannot receive the order book of one NEMO, then you will declare at 12:25 the risk of partial decoupling in stack. In that case, you will try to isolate the NEMO who is creating the issue. At the risk of partial decoupling in stack, you will also trigger the shadow auction process for buying and selling capacity explicitly. At 12:45, if this incident is still not resolved, you will partially decoupled having issues. So at 12:50, you will reopen both the order books for the coupled market without the NEMOs having issue. And you will also reopen order books for the decoupled market on the local side for the NEMO having issue. At 2, you will publish the stack coupled result for the ones that are still coupled. And at 2:45, you will publish the local result. So, having said that, the decoupling impact can be realized at interconnector or order book level, depending on what are your issues for sending the input. If it's CZC, it will be interconnector, and if it's order book, it will be order book level. All the bidding areas that didn't have the issue still participate in those, as I said. There are two special cases, one for the multi-NEMOs setup. As long as one or more NEMOs remain coupled, then the bidding areas and interconnectors still participate in stack. For instance, in the CW market, if you have a decoupling of IPEX and MCO stay coupled, then you won't declare partial decoupling. You will still have all the CWE that stay coupled in stack, and only IPEX will be decoupled, partially decoupled. You have also the special case for interconnectors. If one or more interconnectors can be decoupled at 11:30 without removing the respective bidding zone, then you will keep those bidding zones in the stack coupling. Now let's talk about full decoupling of stack. Full decoupling happens if no bidding area and interconnector can remain coupled due to a full unavailability of the market coupling result at 2. So it's a bigger issue, basically, than the partial decoupling. It's a generic issue and a general issue encountered by all NEMOs, let's say, or the market coupling systems. In terms of timing, you can see that the risk of full partial decoupling of stack is declared at 1:30. At 2, you will have the declaration of the full decoupling. And after 2, you will reopen the order books on local side only. And you will publish the local result at 2:50. So in case of full decoupling, you will only have local auctions. Now, what changes with core? Basically, what will change is the partial decoupling procedures. So in core, as you have seen, the flow-based domain is completely interconnected. And so you cannot decouple one by one any internal borders of the core domain. It means that if you want to run shadow auction for a case of decoupling, you always have to decouple the complete set of core internal borders, internal of external. So what core project did is try to work to find fallback solution optimized to minimize the consequences of a decoupling. And basically, in case of a missing order book, core project has succeeded to create a procedure that will isolate the issued zone and limit the impact of those issues being encountered. What does it mean? And I invite you to look at the picture because it's really more easily understandable than reading the text. If we take the left part of the picture and we take the example of Czech Republic having an issue. So in that case, the red square is Czech Republic. Let's imagine that OT, the Czech NEMO, cannot submit order book to coupling system before 12:45. Then we will try to remove OT for the coupling. So OT will be removed. In that case, core TSO will submit a new flow-based domain, taking into account the issue that OT is encountering and isolating Czech Republic. So in that case, what TSO will send is a flow-based domain put to 0, and they will use the Lta domain that Michael will present just after to isolate Czech Republic. So basically, we go through NTC methodology in that case, because Lta domain will be in NTC. All the borders around Czech Republic will be put to 0, and all the other borders will stay coupled. In that case, JAO will also organize shadow auction for the interconnector linked to Czech Republic. And the other borders will stay coupled within stack, and we will have an allocation process with the NTC methodology using Lta. For the decoupled areas, Czech Republic in that case, you will have local auction run and organized by the concerned NEMOs, so here OT. What changes compared to what exists today in CWE, which is also using the flow-based allocation methodology? Today in CWE, you have an all or nothing methodology. So if you have one bidding zone having an issue within the CWE area, then you will decouple the entire CWE. With core, we succeeded to have a solution that isolates a bidding zone within the core region. The solution will be fine-tuned. Still, we will have eventually some changes after the core go live in order to avoid some adverse effect. Today, for the decoupled bidding zone, so in that case, Czech Republic, you can have transit schedule exchange within the decoupled bidding zone. In the future, we will try to have an evolution to prevent that. And in case of those significant changes, when they will be put in place, we will inform market parties. Now, let's go to the backup, special, or other procedures. So I will go quickly on that part because basically the backup, special, or other procedures won't change. Backup procedures, small reminder, are used to describe the actions that are available to overcome an issue, but an issue which is different than and not covered by the fallback procedure activities. So you have here procedure that covers the case of issue with the cross-zonal capacity submission and allocation constraint submission, and final confirmation of result. They are triggered to ensure that market coupling can still be performed, and they are accompanied by also NEMO-only set of procedures that are backup for the normal ones that you have seen in the first part of the slide. An example of backup procedure, if you have an issue in the exchange of information, for instance, you will use a backup procedure for using the automatized backup system. And in case that doesn't work, you will exchange information manually. Special procedure. They are executed when exceptional situation occurs in the market requiring specific measure to be taken. You have, for instance, second auction or the threshold Nordic Baltic reached. The backup procedure can still be applied during the special procedure. So they are interconnected, they are linked. And then you have the final set, which are the other procedures that are related to plan-specific situation or any other subject that needs a common approach for that level. So a plan-specific situation would be, for instance, the modification of the maximum clearing price. A subject that needs a common approach on that level would be, for instance, the change control procedure or the procedure reading instruction. What will change with core? Basically, with core, we have created a new procedure, which is the rollback procedure. Rollback procedure describes the fact that during 6 weeks after the core go live, you will still have the possibility of trigger of rollback if the following situation happens during 3 consecutive days. Either you have a full decoupling or you have a partial decoupling of core, or the capacity calculation result is in default flow-based parameters. You have a fourth possibility of trigger the rollback, which is serious market issue in the price formation. But for now, this specific situation is not within the rollback procedure because there is no consensus among core NRAs that it should be included. And so we are waiting for NRA guidance to be provided basically to which situation this would address. So what are the serious market issues in price formation? If there is no consensus within those issues, then this won't be added to the rollback procedure, and we will only keep the full decoupling, partial decoupling, and capacity calculation result in default flow-based parameters. What is the rollback? So the process in itself will take 2 days, and the process described to come back to the pre-core topology and pre-core coupling. If the rollback is triggered on day D, then on the day +1, you will still keep the core topology and you will have local auction run because the core participants will be decoupled. On day +2, you will have a couple auction under the pre-core regional topology. So it will take 2 entire days to come back to a coupled market with the pre-core regional topology. Currently, the approach for rollback is core will coordinate with all the DAC regional projects affected. So Northern Italian, ICP, CWE, Polish, Nordic, and Litgrid. And we are all together preparing the rollback procedure. This procedure will be shared with the affected parties. So basically, to summarize, as I don't have a summarizing slide, you can see that the capacity allocation process won't change much with the core flow-based methodology. The only thing that will change is the fallback, which is compared to what happened in CWE. And you will have a new temporary process, which is the rollback, and which will be effective during 6 weeks after the core go live. And I will leave the floor again to Hertian.
Yeah, thank you very much, Adele, for the presentation. In the meantime, we did receive several questions, some more, you can say, household practical questions. One is about the recording, so that definitely it is recorded and will be available after the session, so please be aware of this. And also about the screen, there is also a full screen option at the right lower corner. There were some questions on this. Then now more on the content. We will discuss both the allocation questions, and then afterwards we will go back to Michael, and there are also some questions on the capacity calculation. There are quite some questions, so that's, I think, good. Maybe for you, Adele, and for the direction, it's slide 8 of the presentation of Adele. There was a question about what do you mean with the publication of cross-zone capacities at 9:30 is optional. At slide 8 on the left, it was mentioned at 9:30 that it was optional for NEMOs to publish this information, I think.
The publication is optional for NEMOs, but not towards the market coupling system. For this one, it is mandatory, but then in case of M&A zone, you will have the optionality for publishing the CZCs if several NEMOs are sending the CZC for the same border. So actually, for instance, for the French-Belgium border, Apex are sharing the CZC with the CZC sending to the market coupling system with MCO. And so only one file is necessary to run the market coupling result, even if both are expected. If Apex or MCO cannot send the file, then the market coupling result can be kept, and the CZC for one or the other is in that terms optional.
Yeah, thanks a lot. So I think that was one of the questions. Another one is the euphemia output. It's computed, 70 minutes are given. Is it also monitored what kind of results it would yield if you would continue this for a little bit longer?
It is. We have another system that runs the calculation in parallel, which is called simulation facility. Then I will need to come back to you on that question to know a little bit more about all the outputs that they give. Yeah. But we have parallel runs to try to find the several outputs of the coupling.
Yeah. Thanks a lot. And then another question about the full decoupling procedure. How many times was it implemented up to now? So I think not referring to core, of course, because that's not live, but more in general within STAC. Do you have any idea on this?
I think, but please correct me if I'm wrong, that it happened only one time. Yeah. I'm not sure. I think the most ancient people will know better than I. Maybe Ruth.
Yeah. I remember the same indeed. Not saying that it's then completely correct, but indeed it is really, of course, not something that happens and should happen, and that's also why there's so many mitigations. And then finally, not sure whether it can be answered real shortly, but it's a question: how is the Zono clearing price calculated?
No, for this one, I can give you some more input after the presentation, but it will take too long to explain. But yeah. I can find some presentation to share if you want, if you're interested.
Thanks a lot, indeed, and I think this underlines, of course, it is complex, this computation, so that's also the reason why it cannot be explained maybe in one sentence. Thanks. I think for now, at least these were the questions that I could check before on the allocation part. And if you do have more questions, please keep sending them in. Maybe we can go back to the presentation of Michael Nemi, and also to have Michael again on the screen. Thanks a lot. There's one question about capacity calculation. How much additional capacity becomes available through flow-based versus NTC?
Yeah, that's a very good question, and it's quite complicated to answer it really in general. And the reason is the question is how to compare values which are per CNEC, per critical network element, and values which are per border. And I would therefore like to point you to the KPIs that are presented by the core flow-based group on the Java publication platform, where some comparisons are performed, but it's of course really depends on the assumption and the way how we would like to compare those. So from my personal opinion, the best comparison will be seen or is seen from the KPI, where we present the comparison of the market coupling results using the current approach and then the flow-based approach. So the result we use the results of the parallel run, where we calculate the flow-based capacity every day, and then we use it to simulate the market coupling and compare the results of the simulated market coupling with the results of the real market coupling everyday run. And then there we can see that flow-based provides very often price convergence of the bidding zones, and so that there are, I would say, enough capacity to fulfill all the needs of the market participants.
Thanks a lot, Michael. Clear answer. Then there's also a question: is there any other flow-based methodology next to the one of core in use? And if so, does different flow-based methodologies result in different flow coefficients, so different capacities?
So currently, there is, of course, the CWE flow-based in practice, which is used in the CWE region. And this capacity calculation methodology is different from the core flow-based capacity calculation methodology. There is, for example, a different approach how to apply non-costly remedial actions, or how the long-term allocations are reflected in the methodology. And of course, then it can therefore lead to different results. The core capacity calculation methodology is implemented based on the requirements of the CACM guideline. And based on this guideline, there will be not only core flow-based capacity calculation implemented, but also a flow-based capacity calculation in the Nordics region. And because the Nordic region is, I would say, quite specific, or I would say different than the Central European region, then the methodology will be also a little bit different.
Yeah. Thanks a lot, Michael. So indeed, both the geographical scope, of course, of the region has an impact, but also the methodologies being applied. And that is indeed clear. Maybe if we could go to the presentation on slide 6, there was a question about the subtraction of the internal flows. It said, does it mean internal flows are prioritized over cross-border flows on slide 6 of the presentation of Michael and me?
Yeah, so I can probably answer immediately, even if there are no slides yet. So the internal flows, transit flows, loop flows are subtracted before, and so it could be. I understand your question that you can understand it that they are somehow prioritized. But this is not the case because there is this 70% requirement coming from the clean energy package, which says actually that the remaining available margin has to be minimum. I mean, the size of the remaining available margin has to be at minimum 70% of the thermal capacity of the element. And so another way it says that those internal flows and non-core flows and all these flows which are gathered under the F0 core and also the reliability margin all together have to be lower than 30% of the thermal capacity. And it's up to TSOs to make sure that this is the point and this is the case.
Thanks a lot. There was also a question on the RAM. Are RAM values published before the day-ahead market coupling results, or are they also part of the flow-based calculation?
So the RAM values are the results of the flow-based capacity calculation.
Exactly. Yeah.
And so as nowadays, for some borders, the NTC values are published before the market coupling, then in the core capacity calculation region, we will publish the RAM values as well as the PTDFs for all the critical elements which will be considered in the day-ahead market coupling.
Thanks a lot. And there were also 2 questions more on the representation of the flow-based domain. I think in one of the slides we showed basically a slice of the flow-based domain, and the question was, in reality, it's a d-dimensional bounded convex polytype. But indeed, the representations of both the one of NTC and also the of flow-based are indeed, you can say, simplified, and especially the one of flow-based. In practice, it has many. It's not something that you can even visualize graphically. It's really a long list of PTDFs. This afternoon we have a presentation on the publication tool, and there basically you see the representation of the flow-based domain with all the PTDF values, but it's not a graphical presentation of something. It has too many dimensions to be shown like this.
Exactly. So all the examples which were provided and will be provided later on are simplified in order to be nice and easy to use for explanations, because yes, really the PTDF coefficients are available for all the bidding zones, and if we talk about zone to zone PTDFs, then can be calculated for every combination of two bidding zones. And of course, there are also hundreds of connects, so we will not show that because it would it's not necessary for the, I would say, educational part of the presentation.
Thanks a lot. And then maybe a final question, because we have to also move to the next presentation, and afterwards of again Michael, and that's about will the flow from more expensive zones to cheaper zones increase after implementation of core flow-based market coupling?
Yeah, I would say that the advantage of introduction of flow-based market coupling is that there will be the capacity available there will be more capacity available for the direction which are needed or wanted by the market participants. So in other words, if there is a huge price spread, there will be more capacity on that border, or probably will be utilized there. Not the capacity will be there, the capacity is in the flow-based world, I would say, on the connects everywhere, but it's very probable that the Euphemia algorithm will utilize the capacity for the trading between the countries with a bigger price spread, because then there the trading brings the bigger welfare to the market. But I think it is more question for the market coupling part and for Adele.
Yeah. Okay.
Okay.
I think that's it in terms of Q&A. Let's move to the second presentation of Michael, again on the core flow-based capacity calculation, but then in more details on the process.
Exactly. So good morning once again for the third time already. And this time I would like to really deep dive into the flow-based capacity calculation methodology, which will be implemented in a core capacity calculation region. Okay, so firstly, I would like to talk a little bit about the legal framework based on which the core capacity calculation methodology was created. So there is the guideline on capacity allocation and congestion management, also called in short the CACM regulation from 2015, which let's say divided, or based on which the Europe was divided into the capacity calculation region. And it was also decided that in the core capacity calculation region, which is shown on the picture, the flow-based day-ahead capacity calculation will be implemented. TSOs prepared their proposal for this methodology and submitted it to the core NRAs, which was then, with some amendments, approved by the ACER decision in the February of 2019. And this is the, I would say, core basics of our methodology nowadays. And why I'm talking about basics, the reason is that meanwhile TSO submitted already their first amendment, which reflects, I would say, mostly some struggles which we have encountered when implementing the methodology. And so this first amendment was submitted by core TSOs to core NRAs, and then later on approved in May 2021. And so when we will be talking now about the core capacity calculation methodology, I will be talking about the current status, which reflects also the changes induced by the first amendment from the May of this year. If you are interested in those methodologies, they are of course available online, either on the sites of the core NRAs or, for example, on the sites of ENTSO-E. The capacity calculation consists of 4 main steps. First of all, it's the delivery of the computation data, of the inputs from the core TSOs. This is really important because without a proper predictions and very precise prediction, no precise calculation can be done. Then these data are used to perform the calculation itself, which is, let's say, step 2. In the third step, TSOs has the right and possibility to validate the results, because the whole calculation is actually performed centrally by a coordinated capacity calculator, and TSO has, I would say, no possibilities to really check that the whole calculation was performed correctly. And so there is this very important step of capacity validation. And then based on the feedback provided by the TSOs in the validation, the final computation is performed. This is quite general description, and we will get really into details of every step later. There are multiple actors involved in the process. This is also very important to mention at this point. Firstly, it's the transmission system operators of the core capacity calculation region, or in other words, the core TSOs, whose responsibility is to calculate and provide the calculations. Then there are the regional security coordinators involved in the process, or shortly called the RSCs. In core capacity calculation region, there are 2 RSCs, the companies TSCnet and Chorizo, and they are responsible for merging the grid models, optimization of the non-cost remedial actions, and some other tasks, which we will describe later. Then there is this really important role of the Coordinated Capacity Calculator, CCC, who performs the coordinated calculation. This task is performed by TSCnet and Chorizo, who take turns in the calculation and provide also backup for each other in case there would be some unavailability at site of one of those. Last but not least, there is also the auction office involved in the process. The JAO provides the information about the capacities that were sold, allocated in the long-term auctions, and is also responsible for publication of the results. On this slide, I would like to present you the whole day-ahead capacity calculation process. I mean, you may be overwhelmed by all the boxes and timings and everything, but just don't be, because we will go in this presentation really through each and every box in this schema, and we will describe in detail what is done in every step of the day-ahead capacity calculation in the core capacity calculation region. What I would like to, however, show you on this picture, and what is the message which I would like to deliver to you in this slide, is that the process is quite complex. That's the first message. The second one is that the process starts in D-2 in the evening and continues through the whole night and morning till the morning of D-1, when the capacities are finalized and published and provided to NEMOs. And then that there are many parties involved in the whole process, and different tasks are divided among them. So we can see different rows in this scheme, and we can see that the rows are allocated to different participants. So core TSOs are responsible for the tasks which are in the first row, RSCs for the second row. The whole third row is then done in a coordinated manner by the coordinated capacity calculator. And then there is also task by JAO. So let's go to the first process of this very complicated scheme. So first process of the capacity calculation is the provision of the input data. Input data are provided by core TSOs and also by JAO. JAO provides information about the long-term capacities that were sold, in other words, allocated in the yearly and monthly auctions. This needs to be done at the beginning of the whole process. Then there are 4 basic inputs that are provided by the core TSOs. It's the individual grid model, which is the representation or prediction of how the network will look like in the day of delivery of the electricity. Then that's a list of external constraints, then a file of generation load shift keys, and then lastly, a list of critical network elements. So these inputs are really important because really quality and of the input really determines then the quality of the outputs. And so for this reason, I would like to really go through these inputs one by one and tell you what is included in them. So firstly, I would like to talk about the D2CF individual grid model. D2CF stands for the fact that the model is a 2-day ahead prediction of the status of the power grid. It includes best prediction TSO has about the generation, about the load, about the grid topology, about the planned outages such as maintenance. And this is all in this file. It's actually 24 files because TSO makes separate prediction for every hour of the day. This file is, when provided to the process of capacity calculation, is then merged by the merging entity to create the common grid model, which is the, I would say, most crucial and fundamental input for the whole capacity calculation. Next input, which can be submitted to the capacity calculation process, are the external constraints. What are the external constraints? External constraints are allocation constraint that limits the maximum import and export of a given bidding zone. This external constraint can be used only in very specific cases. And those cases are when operational security limits cannot be really transformed efficiently into network elements limitation. So in other words, if the security limits in the network cannot be modeled by the critical network elements and their RAM. Usage of external constraints is really limited to just few TSOs for whom the usage of these constraints was allowed and approved by the core NRAs. And those TSOs are also mentioned in our capacity calculation methodology in the appendix, where you can find also the justification why they need to use these external constraints. The third input are the generation load shift keys. This is a file which describes how a change in a bidding zone net position is translated into a specific change of injections and withdrawal in the common grid model. In other words, it says that if a bidding zone's net position is changed, which generation units and which load will participate on it and how much. So this file is defined by the core TSOs individually based on a historical behavior of these generation units and load units. And it is used quite often in the capacity calculation process. And as an example of usage of this file, just imagine that you would need to change net position of one bidding zone by 10 megawatts. And the question is how to do it. So the GLSK file tells us on which generation units the production should be increased, or on which units or on which loads the consumption should be decreased. The last but not least input file is the so-called Cbco area file. It's a list of critical network elements with associated contingencies and also a list of non-costly remedial actions. So let's talk about each each part of the file separately. Firstly, it's the list of the network elements with contingencies. By network elements, we mean overhead lines, cables, and transformers. By contingencies, we mean unplanned outages, which are associated to those network elements. So, in other words, fulfilling the N-1 criterion. On the lower part of the slide, I present you an example of such a network elements list. So we see here 4 critical network elements. And in the first column, we have a unique identifier of each of these critical network elements. In the second column, we see the name of the element, which is a power line between Hradec and Etzenricht, so between Czech Republic and Germany. And we see that in the third column, that each of the line is defined twice. Firstly in one direction and in the opposite direction. So in direction from Czech Republic to Germany, and then in direction from Germany to Czech Republic. To every critical network element, a contingency can be associated, or it doesn't have to. And this we can see in the last column, where we can see that the line from Hradec to Etzenricht is firstly defined in a base case, which means without any contingency, and therefore the values, the RAMs and PTDFs will be calculated for disconnect for the situation which is in the common grid model. But for the connect number 3 and 4, there is a contingency associated. So there is a unplanned outage on the line between Preštica and Etzenricht. And this means that to calculate RAM and PTDF for this connect, there needs to be a change made in the common grid model. So in other words, an outage simulated for the line Preštica-Etzenricht. The network elements with contingencies can be defined by TSOs in 2 different manners. There are 2 types of the network elements with contingencies. Firstly, they could be defined as the critical network elements with contingencies. And those critical network elements means that those elements are relevant for the cross-zonal exchanges and should be used for the flow-based capacity calculation, and then they can limit the flow-based domain. Currently, those can be both internal and cross-zonal elements, but 18 months after the implementation, and then later every 2 years, core TSOs have to submit a list of internal elements that they would like to keep as a critical network elements with a detailed justification, and only if this justification is acknowledged and those elements are approved, they can be used as a critical network elements. It's also possible to define network elements as so-called monitored network elements, NECs. Those cannot limit the flow-based domain, but they are monitored during the non-costly remedial action optimization process, which we will get to it later. Then the Cbco array file includes also the non-costly remedial actions. Non-costly remedial actions are changes in the grid topology and or also phase shifting transformers. These are provided in the Cbco array file and are used later on during a process of optimization of non-costly remedial actions. TSOs have to provide all expected available non-costly remedial actions to the process. After all the input data are provided to the process, then of course a data quality check follows, where it is checked whether everything is correctly submitted. There are actually two rounds of the check. First is the syntax check, where our files are controlled, whether they include all the necessary fields and whether the format is correct. And then follows a more important coherence check. In this stage, the files provided to the capacity calculation are checked for coherence among each other. In other words, or as an example, just imagine that TSO sends a list of critical network elements for which it is interested to get RAM and PTDS, but at the same time, those critical network elements are not in the common grid, in the individual grid model, which was provided by the same TSO. So this is what the coherence check controls. And if there is some error or some warning, it is provided back to the TSOs. And TSOs have opportunity to correct their data and resend them again to the process. When all the input data are already correct, then we can proceed with merging of the inputs. And most importantly, merging of the individual grid models. So as every TSO sends its own grid model with its best prediction for today ahead, then it's necessary to merge all these models into one common grid model, which is used for the calculation. This task is performed by the RSCs in a role of merging entity. For the purpose of achieving a balanced CGM model, which is really important, for this reason, we also shift the net position of the different bidding zones, so different IGMs, towards a consistent forecasted net position. So there is a process where we forecast also the net position centrally, and we shift individual grid models of the TSOs to this precise forecast, which is not only precise, but also ensures that the whole common grid model will be balanced. And when we have all the input data merged, we have a common grid model, we can proceed with a first flow-based computation using those inputs. Why I talk about first flow-based computation, the reason is that during the flow-based process, there are multiple adjustments and the computation of the flow-based parameters itself repeats multiple times. And therefore, you will see in this presentation some extra descriptive adjectives before the flow-based computation, such as initial flow-based computation, which is the first one. The result of the initial flow-based computation is the list of the critical network elements, and for every element there is a RAM, remaining available margin, and a matrix of PTDS. PTDS are coming simply from the situation in the common grid model. And they can be expressed in two forms. And as you will probably use some flow-based results, I would like to explain to you the difference between two forms of PTDFs and the transformation between them. So there could be either zone to select PTDFs, which describes the sensitivity of the given network element to a change of the net position of one bidding zone. So how much more loaded will some element be in case the net position of one bidding zone will increase? Or there are the zone-to-zone PTDFs, which I have presented already before in my first presentation, which describes the sensitivity of a network element to an exchange between two bidding zones. And of course, those two values or two representations can be linked one to each other. And using the following equation, which we can see on the bottom of the slide. So if we would like to receive zone-to-zone PTDFs, between bidding zone A and B, we can simply get it from the zone to slack PTDFs, which are very often published, by just subtracting the PTDF, zone to slack PTDF for zone A minus PTDF for zone to slack B. And how we will get the RAM value? Okay, the RAM value will be obtained, as we have already seen in the first presentation, by simply subtracting from the thermal capacity Fmax the flow reliability margin, so the reliability margin, and some default flows, here signed as F reference. And as an example, we can see here a list of critical network elements, each of them having RAM, which was calculated as Fmax minus FRM minus F reference, and a list of PTDFs for these elements. And on the right side of the slide, we can see a graphic representation how such a flow-based domain would look like. Similar slides will be presented also later in the presentation. Just to be honest, I wanted to make the presentation as more explanatory as possible, and therefore I always present to you firstly some theoretical slide explaining some substep of the flow-based capacity calculation, and then it will be followed by an explanatory slide like this one, where we will see what will happen to this initial flow-based domain later on in the capacity calculation. I would like to also draw your attention to the picture on the right, that there are two types of limitations. Some red limitations are in bold, and some are a little bit shady. Both of those limitations are the connects limiting the flow-based domain. But it's obvious from the picture that the shady lines are not effectively limiting the flow-based domain. It's just the bold red one who are limiting the flow-based domain. So when moving from the origin of the two axes, I will firstly reach one of the bold red limitation before reaching the shady one. And so the shady limitations are actually not necessary for the calculation, and we can leave them out. For example, when providing the final flow-based results to the NEMOs. It also helps us to improve the performance of the calculation. To make it easier to distinguish between those two types of limitations, so the bold one and the shady one, which is not a really nice word how to distinguish them, we call the bold one the pre-solved flow-based parameters, and the shady one non-pre-solved. I may use this term later in the presentation. After the first initial flow-based computation is performed, there is a possibility to we have already the PTDFs. I'm sorry. We have already the PTDFs and RAMs, and at this point, we would like to filter out all the critical network elements whose zone-to-zone PTDFs or maximum zone-to-zone PTDF is smaller than 5%. Why to do this? By filtering those critical network elements, we get rid of the elements which are actually not sensitive to cross-border exchanges, and therefore they are not relevant to the calculation. So if the PTDFs describes the sensitivity, then we can definitely leave out those elements whose sensitivity is very low. And the threshold that we have set is 5%. To be completely honest with you, those elements are not completely erased from the calculation, but their status is changed from critical network elements who can limit the flow-based domain just into monitored network elements, which are monitored during the remedial action optimization. But we will still keep them in the calculation, but it will still help us to make the calculation more efficient. On an example, which is seen here on in this slide, we can see that there is some initial pool of critical network elements as they were provided by the TSOs, who provided a list of network elements and some contingencies associated to them. After the initial computation, we will receive information about the PTDFs and the RAM values. And so we can perform this connect selection to get rid of the elements whose maximum PTDF is smaller than 5%. When looking, for example, on connect number 1, we see that the PTDFs are 12%, 10%, and 4%. So this element definitely fulfills the criteria, and we can keep it in. But for example, for the element number 8, there the maximum zone-to-zone PTDF is just 3%. Therefore, we will not use it as a critical network element, and it will stay just as a monitored network element.
Yeah, so thanks a lot, Michael, again, for this first part. So there are different questions that were coming in. Two of them are maybe easy to be answered. What is the difference between core and non-core TSOs? And there was also a question about core and Denmark. Is Denmark part of core? So maybe the answer to this is there's a geographical scope of core and the countries that are represented within this region. And all the TSOs that are part of this geographical scope are also part of core. And that also makes a distinction with non-core TSOs. If they are not part of this geographical scope, then we call them non-core TSOs. So Denmark would be a non-core TSO, but the input of Denmark is at least considered not exactly the same input as for the other core TSOs, but at least the influence of the exchanges are taken into account. Then there were a few questions about transparency. This will be dealt with in the afternoon. So we think it's better to save those questions to the afternoon because most of them will already be answered. Two questions for you, Michael. Why cost remedial actions are not included in social welfare, computation and optimization?
Yeah, so the reason why we use only the non-cost remedial action is, there are multiple reasons. Firstly, we are afraid of the trade-off between applying cost remedial action and then assuming what the welfare welfare gain would be from that, because we are still D-2. And second option is that really at D-2, there is not enough information about the availability of the remedial actions at that point in time where the non-cost remedial action optimization is performed.
Thanks a lot. And there's also a question on the Polish, I think it's called the technical constraint. So it's the combination of, and not only something related to directly core, and it's the question whether this will be remaining after core flow-based day ahead as well. Do you know this answer?
Yeah, Poland is actually one of those countries who applies the allocation constraint or the external constraint, as is what mentioned as one of the input data. And this is, I would say, partly used as a virtual bidding zone, which is used nowadays in the interim coupling topology or the technical profiles which are used nowadays. But in the flow-base itself, there are no technical profiles and there are no virtual bidding zones for Poland.
All right, thanks a lot. There were also still some questions related to the allocation part. So maybe it's good also to give Adele the possibility to answer those. They were coming in a bit later. There's one on the rollback about the Czech Republic as an example, at least. In case of a rollback, would you then return to the Ntc methodology for that specific country?
So the answer is yes. actually we will return to the Ntc methodology through the sending of new LTA values by TSOs. As I said, TSOs will send two files, flow-based domain at 0 and LTA domains containing the Ntc value. So it's a little bit summarized, but yeah, answer is yes.
Good, and there's also a question on intuitiveness, because for example, CDBE, what was implemented in the past is having a constraint for this, making sure that flow is always from a high price zone to a low price zone. Will this remain in core?
I think yes, then I will prefer to double check after the session to be sure, but and my understanding is that yes, it is the case.
And actually, in the core it will be plain that will be implemented, so that so actually no additional constraint to force this flow somehow. That is already decided upon in core. Yeah. One last question, that is, has there been measures taken into account so that Euphemia can handle more complex computations, including flow-based?
So not directly, I would say, but yes, currently we are doing some technological upgrade. Before core, we will have at least 3 different releases of Euphemia that are transparent for market participants, but we are constantly trying to improve Euphemia and the algorithm, and there will be some technological upgrade basically to try to be more performant. But it's a continuous optimization, so I would say indirectly yes, not directly.
Thanks a lot, Adele. So let's go back again to the next part of the presentation of Michael.
Okay. Perfect. So when the initial flow-based computation is performed and the connect selection filters out the elements which are not sensitive to the cross-border exchanges, then we can start with the optimization of the non-costly remedial actions. The goal of this optimization is to expand flow-based domain based on an objective function of this optimization, so in a direction where the capacity is needed. And this is done by applying non-costly remedial actions. What are the non-costly remedial actions? These are the topological measures, which means changes of, I would say, topology or connections in the substations. And then secondly, it's also a changing tap position of PST transformers, the phase shifting transformers. This optimization is performed automatically by 2 algorithms which we have available. We call them CRAAO and HS. Those 2 algorithms are provided one by Chorizo, one by TSCnet. And although they have the same objective function and same constraints, they use different approach, different algorithm to obtain the result. And so it happens that they ended up with different results, and therefore we have there a special module called trial selection module, which for every hour checks the results from the CRAO and HS and compares them and takes only the best result for every hour, which is then used for further computations. In the RAL, only the non-costly remedial actions that were provided by the core TSOs at the beginning of the calculation are considered, and the resulting set of remedial action is actually applied to the common grid model, which is then later used for the calculation. At this point, I would like to mention that the fact that NRAO chooses some remedial action, it doesn't mean that those remedial action have to be activated in the real time as well. The reason is that RAO also have some assumptions when applying those remedial action, but no one knows what will be the real outcomes of the day-ahead market coupling, which can be, they shouldn't be, but it can be different from our assumptions. And what is more, there is the D-1 operational security analysis performed by the TSOs, where it is decided what remedial actions will be actually applied in the final for the real operation. On an example of the flow-based domain, let's assume that we have the domain from the initial flow-based computation, and our objective function says that we should increase the flow-based capacity in the direction of the black arrow. If it is the case, and then there are some remedial actions which can increase the capacity in that direction, then they will be applied by the NROW. And it will result in an increase of the capacity in that direction. But it is also very important to mention that it will probably also decrease capacity on some another element, because by applying non-costly remedial action, the net position of the core bidding zones is not changed. So the amount of electricity that is produced and that is consumed is still the same. But what is changed is the way how the flows go through the network. Because either when applying topological measures, the real topology of the network changes, or by applying PSTs, just some parameters, in other words, we can say some parameters of some lines changes. And so the flows goes in different direction. On our flow-based domain in the Excel, it has that impact that this reference flow or the F0 core is changed, because the flows which are in the network will flow differently. Then follows the intermediate flow-based computation. Why to recompute the flow-based domain? This is quite obvious, because we have changed the critical network elements list, because we have filtered some insensitive elements. That's first. And secondly, we have a little bit different common grid model, because we have applied non-costly remedial actions to it. And so when we reperform the flow-based computation, we will get a little bit different results than we have got from the initial flow-based computation. So the result of the intermediate flow-based computation is the set of REMs and the PTDFs again. I would like to draw your attention to the fact that up to this point, the whole calculation was based on the pure physical laws. So we used the common grid model, and in that model there are real electrical parameters of the lines, and based on that we calculated how the flows will flow and what the PTDFs will be. But after the intermediate flow-based computation, there are two steps which leads to increase of the flow-based capacity based on some legal requirements. And this increase is, from my perspective, artificial and can lead to a potential risky capacity from the point of view of operation security. Those two steps are the adjustment for minimum RAM and the inclusion of the long-term allocated capacities. And let's get to those steps right away. So first of these steps is the adjustment for minimum RAM. The aim of this step is to secure that the specific percentage of the thermal capacity of all elements is reserved for the commercial exchanges. And by commercial exchanges, we mean both the core commercial exchanges and commercial exchanges outside the core capacity calculation region. In our capacity calculation methodology, there are two conditions related to this aim. One is coming from the clean energy package from the Article 16 of the Regulation 2019/943, which says that at least 70% of cross-owner capacity should be available for commercial exchanges. Of course, if a derogation or an action plan is not granted, then this percentage can be lower for some period of time. And our core capacity calculation methodology goes even beyond this very strict requirement. And it says that we should also guarantee that there is a 20% of the thermal capacity available for the internal core commercial exchanges. So 70% for all commercial exchanges, and at the same time 20% for internal core commercial exchanges. In the computation, this condition is done by increasing artificially the RAM value by a capacity adder, which is called adjustment for the minimum RAM, or in short, AMR. Here on this lower part of the slide, I would like to present you the real equation which is used in our algorithm to ensure that the 70% and 20% requirement is followed. So the AMR is this adder, and it is calculated as a maximum of 3 parts. Let's start from the end of the bracket. So it's either 0, which makes sure that the AMR is always non-negative. In other words, that is always increasing the RAM, never decreasing it. Then there is the second or the middle part. And here we can see in the bracket Fmax minus FRM minus F0 core. So this is, in other words, RAM. So it says that 20% of thermal capacity minus RAM is the AMR. So if the RAM is smaller than 20% of the max, we will get positive value, which will be the AMR by which we will be increasing the RAM. And then we have the first row, which describes the complicated requirement of the clean energy package. This RAMR is 70%, or if there is derogation or action plan granted, it can be some lower value. Let's assume 50, 70, 60. It can be anything based on the derogation or action plan. And FUAF are the flows which are coming from the non-core exchanges, commercial exchanges. So in other words, the first row says that if we subtract from the 70% requirement the non-core commercial exchanges and the RAM, what we will get, if it's a positive value, that's how much we should increase our RAM to ensure that 70% is granted for the commercial exchanges. On an example of a calculation, we can see that just let's assume that for CNEC number 4 and 5, there is a requirement that 55% of thermal capacity should be offered for commercial exchanges. By pure calculation of RAM as a Fmax minus FRM minus F0 core, we will get that the RAM is 500 megawatts. And so, therefore, there is a AMR adder applied 50 megawatts to increase the RAM to the requirement of 55%, let's say. So this is just artificial increase of the capacity, which is not based on any physical computation or some physical laws in the network. And this can be, of course, potentially risky for the operation of a grid with such capacities. And this will be handled later in the capacity calculation.
So the Q&A again, thanks a lot, Michael. Again, several questions came in. There was a question on the IGMs in general and input if that is missing. So maybe shortly on this, for IGM, there are, you can say, replacement strategy, meaning that if a single input is missing, this can be replaced. And that's such backups are defined for many of the inputs. Then there's also a question for you, Michael. Can you give a more concrete example what exactly put in the FRF flow? For example, with regards to the DA Swiss flows, is it then the case indeed that these flows, since Swiss is not part of core, would affect the RAM on a core net element between Germany and Swiss?
Yeah, so there are actually, I understand it as two questions. Firstly, the reference flow initially is represents all the predictions on flows that we have in the grid. So when we take the merge grid, so what are the flows there? So this is F reference, which is used in the initial steps of the calculation, and it's really important for the remedial action optimization. It is later on in the calculation, and then for provision to the market participants and NEMOs, it's then not used anymore, and it's instead we use the F0 core, which are just the internal flows and non-core exchanges as it was described in the original presentation. Regarding the influence of Switzerland, this is a quite specific topic because there is cooperation between Switzerland and core region, and we plan to implement some coordination in the capacity calculation. In other words, the capacity calculation process of Switzerland and core will communicate with each other, and we will share information about our connects. Yeah.
Good, thanks. And then maybe related to this, yeah, there's also a question on if for the TSOs that have this link to third countries, if flow-based is the best, providing the best outcomes in terms of operational security and cost effectiveness. And I think the answer is here a little bit that for the core internal borders, because core is a meshed grid, flow-based is seen as the best solution. And having this and a connection to the external borders, this is something you simply have to deal with somehow. So indeed, this combination is still seen as the most effective setup. Then a short question on RAW. You mentioned the selection of the RAW. You take the one that's giving the best results. What means the best results in this perspective?
Yeah, as I've mentioned, non-cost remedial action optimization has an objective function, which is described in detail in our capacity calculation methodology. I would not like to go really much into detail what's the objective function because it's quite complicated. It's just some maximizing of minimal relative RAM, in short, which is quite complicated. But as this is the objective function of the optimization, then we can, based on the value of this objective function, choose easily which of the tool is better.
And better means then providing more capacities then.
Mm-hmm. Yeah. Better means providing more capacity, and in other words, it's having better value of the objective function.
Perfect. Thanks a lot. Last question. What is the typical number of connects for core before and after pre-solving?
That's a tricky one. I have never analyzed that, but I would say that before pre-solving, it can be thousands of connects, 5,000, 6,000, maybe more even. And after pre-solving, it's like 1 to hundreds.
Yeah, well, I think that gives an idea on the size of this and the numbers, of course. Good, then I think we can continue to the next part.
Mm-hmm. So next part of the capacity calculation is the long-term allocation inclusion. What are the long-term allocations? Those are the transmission capacities that were sold, or in other words, allocated, during the yearly and monthly auctions. And when allocated, their owners have right to use them, to really use them for physical transmission of electricity, in other words, to nominate them, or not nominate them in case that they are physical transmission rights, or even if they are, and if they are financial transmission rights, those cannot be nominated. And if the long-term allocations are not nominated, TSOs shall remunerate the owners of these rights with the price spread of the day-ahead market. So in other words, in the day-ahead market, TSOs receive money, which is called the congestion income, which is based on the price spread between the bidding zones. And using this income, TSO shall remunerate the long-term transmission right holders for those rights that were not nominated, that were bought, allocated, but they were not nominated. Either because owners didn't want to nominate them, or because those were just financial transmission rights that cannot be nominated. What can, however, happen is that the long-term rights that have been already sold in the yearly and monthly auctions are larger than the capacity that were calculated in the day-ahead capacity calculation process. This can happen quite easily because there are different assumptions which are available to TSOs a year ahead or month ahead. And in a daily operation or day-ahead operation, TSO has more precise data available. But then the question is what to do in such a situation, because this would lead to the issue that because we as a TSOs have to be prepared for the situation where none of the LTA, long-term allocations, are nominated, and then that they all have to be remunerated. But if the long-term allocations are larger than the flow-based domain, then it can happen that there will be not enough money collected in the day-ahead auction or in the day-ahead market coupling. And for this reason, it is necessary to increase the flow-based domain in such a way that it always covers fully the LTA domain. And there are multiple ways how to do this. And in core capacity calculation, we have considered two approaches. Firstly, we considered something called the Lta Margin Approach, which was used in the original core day-ahead capacity calculation methodology, but in the amended methodology, it is used only as a temporary or rollback option. And the reason is that this approach can be potentially very risky from the operational security perspective. Lta margin just works in the way that the RAM of a connect, of a given connects, is increased in the way that the Lta margin is completely inside the flow-based domain. So on the example on the left side of the slide, we see that the Lta domain goes beyond the flow-based domain. And to solve this issue, we could just increase RAM on connect number 2, and by doing so, we would just shift it in parallel to its original position a little bit up, so that the Lta domain would be fully covered in the flow-based domain. But by doing so, we would not only include the Lta domain into the flow-based domain, but at the same time, we would also introduce a lot of extra capacity to the flow-based domain, which are not based on any technical calculation and are therefore potentially risky and can cause issues in the network. So from the perspective of operational security, this is undesired solution. Therefore, there is a better way how to perform the inclusion of the long-term allocations. And this better solution is called the extended Lta formulation. So if we look at the same example as we had before on the left side or on our side, now there is a convex hull, which is a blue line created that covers the Lta domain. So adds it into the flow-based domain, but at the same time adds a minimum of a potentially risky capacity, which are the yellow points, which are under the blue line that have not been originally in the Lta domain nor in the flow-based domain. This concept of the extended Lta was already proved in Cwe that it actually leads to comparable min-max and net position and welfare with the virtual branches approach that is used nowadays in the Cwe. Unfortunately, in the core capacity calculation region, it is not possible to determine directly the convex hull. And so when we like to apply the extended Lta formulation, the result of the flow-based calculation are two domains. Firstly, it's the flow-based domain without Lta inclusion, and then separately the Lta domain. And then when these data are handed to Euphemia, then the market coupling algorithm called Euphemia automatically performs the Lta inclusion when optimizing the day-ahead market. Yeah. So the biggest benefit of the extended Lta formulation in comparison with another ways how to include Lta domains into the flow-based domain is that it fulfills completely the coverage of the Lta domain. But at the same time, it just really limits the extent of potential unsecure, we call it virtual capacity. On an example, it would look, so after the Lta inclusion, the flow-based results would look like this. So we would have two domains as a result of the flow-based computation, the pure, or sometimes referred to as a virgin flow-based domain, and the Lta domain. And maybe you are wondering, yeah, that's nice that there will be two domains, but how to work with that? How to find out whether some market clearing point or market point in general lies in the convex hull, if this convex hull cannot be described. And here I would like to present to you a so-called Ballast Approach, which is a helper function to understand the extended Lta formulation. It is a way how to verify whether a given market point is feasible by the day-ahead cross-zonal capacities, or in other way, by the capacities formed by the Lta domain plus the flow-based domain. The Ballast Approach is actually a linear optimization algorithm. Here, I would like to describe you a little bit the function, how the linear optimization algorithm works, so that you can create it yourself if you are interested in checking the capacities. So first assumption of this process is that the net position the net position that I would like to check, so the market point, can be divided between the Lta domain and the flow-based domain. So I can split it. And then also the limitations of the flow-based domains, so the RAMs, and the limitation of the Lta domains, which are some NTC values, can be scaled by a coefficient alpha, which is between 0 and 1. And so one domain is scaled by alpha, and second one is 1 minus alpha. And if we set an objective function that we would like to maximize our market point, which we would like to check, and put there a constraint that flow resulting from the Lta market point is smaller than the scaled Lta domain, and that the flow resulting from the flow-based market point is smaller than the flow-based domain, and we run this optimization, we will get a maximum, like our market point maximized. By that mean, we will get a market point which lies directly on the borders of the ballast domain, so of the convex hull. So an example here on the left, so if we start in point 1, with the optimization, we will end up in the point A with hyphen, so at the edge of the extended Lta domain. If we would start already in point 3, for example, which is outside the flow-based domain, then by the optimization, we and fulfilling this criterion which were described, we would end up in the point 3 with hyphen, so at the borders of the domain.
Thanks again, Michael. One question remaining, and also for the participants, the Q&A will be also published after the meeting. Michael, can you put your camera on? I have one question for you. It would be good to see you. It says, we were told that in a domain space, every line representing a knack and its slope can represent PTDF. Can you define mathematically this slope? So I think they're referring to the coefficients, the PTDF coefficients, and if you can mathematically define this.
Of the knacks, yes,
yeah, indeed.
It's possible to do it.
Yeah. So the answer.
So for example, in two-dimensional space, it's just a line, so it's very easy to determine 2 points in the space, and then just draw a line.
Yeah. Now, and I think part of this probably will also be dealt with in the afternoon in the publication transparency part. I think the combination of net positions and the changes of this and the coefficients of the PTDFs. I mean, making this link, then indeed you could define this. The slope is already defined, but you could also visualize this indeed. But maybe after the afternoon's presentation, this becomes even more clearer. There's still one question I'm getting informed. On the issues of LTA potentially ending up to be too large, how is it ensured that the enlargement is not discriminatory against implicit allocation of cross-zonal capacities? Also, are the amendments made to solely address real physical constraints or in parts to alleviate indirect economic risk of TSOs due to ESDA congestion revenues, ending up in a few cases lower than required LTA? It's a long question. Did you catch it, Michael? Or?
I got some parts of it, so I will try to answer a bit. But I think that the question is quite complex, so it would be better to answer to it in detail after the workshop. But in general, by introducing the LTA inclusion, we are just increasing the domain so that there is enough capacity in the day-ahead market in case that the capacity is not nominated. But it doesn't mean that we would reserve this capacity for some purpose. It just means that we will increase the capacity, which is then provided to the market.
Good. Thanks. Maybe we'll answer some more questions later on, but good to now move forward to the next part.
Okay. Perfect. So the next step of the flow-based computation is the validation. As I have already mentioned in the beginning of my presentation, the whole process is centralized, performed by the capacity calculation coordinators, and TSOs how to say? I mean, the involvement of TSOs in the whole process is quite limited to some sub-processes. So TSOs send in the input data, and then after the intermediate flow-based computation, they have possibility to validate the results. Objective of the validation is to identify and apply measures for resolving the potential violation of operational security in the intermediate flow-based domain. And this can really be the case because, as it was mentioned in the last 10 minutes, there are some steps which artificially increase capacity beyond the physical nature of the grid, and this increase can be potentially risky. And we can honestly say here that it can be risky. It doesn't have to be, and that's actually the reason why there is a validation. And in this step, TSO shall use all their expected available non-costly remedial action, but also the costly remedial actions, such as redispatch, to check whether the capacities calculated by the intermediate flow-based computation and enlarged by the adjustment for minimum RAM and LTA inclusion are really secure from the operational point of view. And the validation itself consists of two steps. Firstly, it's the coordinated validation, and then there is also an individual validation. Coordinated validation is performed by the coordinated capacity calculators, RSCs, in cooperation with TSOs. And The aim of this validation is to firstly exchange information on those expected available remedial actions, which all TSOs have to send to the RSCs. And then using those RSCs, using those remedial actions, RSCs validate whether the flow-based domain is secure. But if there are not sufficient remedial actions to secure security of the system, then it's possible that relevant TSOs, in coordination with the capacity calculation coordinator, may apply some validation adjustment called CVA, coordinated validation adjustment, and by that decrease the RAM. To put it more simplified, just so let's say RSCs take the capacities and try to check in the network what would it mean if all the capacities were used fully in some direction. That's also based on some our expertise and predictions. And if those capacities were fully used, will the network will be overloaded? And if yes, will we have sufficient remedial actions to solve these overloads? If yes, it's fine. If not, if there are not sufficient remedial actions to solve the overloads and another probably also issues with security which can occur in the network, then there is a possibility to decrease RAM a bit. There is actually gradual implementation of this coordinated validation. So initially there will be just simplified approach for the first years of operation, which consists of exchange of information on the available remedial actions. So TSOs sends their remedial actions to the RCs, and RCs then distribute them to the TSOs back. They merge them and distribute them back so that TSOs can use them in their individual validation. Later on, there will be a full approach, which will include also the coordinated assessment, as I have described it just a few seconds ago. This full approach is not specified in detail yet, but there will be a TSO proposal prepared, and it should be prepared at latest by 18 months after implementation of the core flow-based market coupling. After that follows the individual validation, which is already now in place and it's working. This validation is performed by the TSOs individually for their own control area, and TSOs can apply some individual validation adjustment, also decreasing the RAM in 4 explicitly mentioned situations. Firstly, it's if there is some occurrence of an exceptional contingency or force outage, or where all available remedial actions are not sufficient to ensure operational security. In exceptional cases, if there are some big mistakes in the input data that would lead to an overestimation of the capacities, or that if there were a potential need to cover reactive power flows on certain connects. In very exceptional cases, there is also possibility for TSOs to add internal critical network elements into the final list of critical network elements. And this is possible only if all remedial actions are not sufficient to ensure operation security on an internal network element. So this point would apply more later when it will be allowed to have just the cross-zonal elements in the flow-based computation. And in some exceptional cases, we would add an internal line. Of course, I would like to ensure you that application of this individual validation adjustment is subject of detailed reporting, both to NRAs and also to all the market participants. So application of IVA together with a justification will be available on Java publication platform for you. How an application of IVA looks like on a flow-based domain, it's just another component to the equation how to calculate the final RAM value. So the final RAM value is calculated as a RAM before validation, from which we would subtract coordinated validation adjustment and the individual validation adjustment. On the picture of the flow-based domain, it would just mean that some CNEC limitation would be moved closer to the origin.
Good, thanks a lot, Michael. Minding the time, we cannot answer too many questions. There were still some questions on the Ballast method, especially about, is the domain, LTA domain included in the final PTDF domain, and also why it's needed to have this separation of those two domains. And I think the short answer would be there are two domains, indeed. So it's not that the one is included in the other. There are two separate domains, you can say, sent for market coupling. And this is because it's more efficient to let the market coupling algorithm check those constraints rather than merge them first during capacity calculation. So that is the main reason. And it's also not that there are two market clearing points, but two market points. So there are two domains. That's maybe important to highlight. Let's maybe continue to the next part, Michael.
Okay, so after the validation, we have, let's say, another inputs for the computation, and so we can perform a pre-final flow-based computation, which takes as an input all the data from the previous computation and extra, of course, also the information from the individual and coordinated validation. The result of this computation is the flow-based domain, let's say this pure pre-solved flow-based domain, and also the LTA restrictions or the LTA domain. And these values can be, let's say, considered as a final. The only missing piece of puzzle are the information about how many capacities, long-term capacities, were actually nominated, which is not available at this time. But besides, the values are already final, and so they are also already sent to job site for publication. A little bit later, when all the long-term nominations are available, the final flow-based computation follows, and it means that the flow-based domain, LTA domain, is recomputed, and from the result, the long-term nominations, so how many long-term capacities were really nominated, is subtracted. And so we will then receive the real final capacities. On an example, let's assume that we have a flow-based domain, an LTA domain, so the final flow-based capacities, and to subtract the long-term nominations, we can understand it that some capacities were already solved and used and should therefore not be, let's say, offered to the market one more time. And so, in other words, we will subtract the long-term nomination both from the flow-based and LTA domain. Graphically, that it's similar to shifting the flow-based domain in the space. After we have the final flow-based domain, the results are published and sent also to NEMOS to perform the market coupling. I would like to also inform you that we have some fallback options available in case there is some issue with the flow-based capacity calculation. Fallback can be triggered in case there is a technical failure with the tool, with the central tool. There could be also some error in the communication or corrupted or missing input data. We are prepared for all these tasks or these problems. And if they occur, we have, I would say, 3 possible fallbacks in our sleeves based on the severity of the problem. So first of them is to reuse the initial flow-based computation results for the final flow-based computation. That's if there is some issue in some of the sub-steps during the calculation. If, on the other hand, there is some real fail of some timestamp during the flow-based computation, we can either use spanning or default flow-based parameters. Spanning is a method that is applied in case the flow-based computation fails strictly for less than 3 consecutive hours. And in that case, we would just use as a fallback a union of previous and subsequent available flow-based parameters and all Lta domains. So this can be seen on the picture below on the slide. So let's assume that we had successful computation for timestamp 1 and timestamp 3, but the computation failed for some reason for timestamp 2. In that case, we would use spanning to get some values for the timestamp 2. And so we would take union of the timestamp 1 and 3, which is the red shape polynomial in the middle that would be used. If there are more failed hours, then if there are 3 or more consecutive missing hours, then we would have to apply the default flow-based parameters, which are NTC capacities based on Lta capacities, which are increased by some adjustment values, which are provided by TSOs for every border they have. And then by harmonization principle, those adjustment values would be selected. So we would take smaller from the 2 adjustment values for a border, and then the adjustment would be added to Lta capacities. So that's, I would say, the last default parameter. Last measure how to solve the issue.
Thanks. So again, some questions, 2 of them. One is related to the IVAs. If you apply these, it will be monitored against abuse to manipulate offered capabilities. And I think you already mentioned before, Michael, that indeed the reporting is extensive to regulators. So this is definitely monitored indeed. Another question is on the remedial actions, the remedial action optimization. Whether this process and the input that they send, TSOs, is that different for the validation compared to the remedial action optimization?
Yeah, I mean, it's quite different process. In the non-costly remedial action optimization, the target is to increase the capacity and then to apply the chosen remedial actions in the common grid model. In the validation, TSOs are just checking that they have some remedial actions available in case that the capacity would be used in some way. So they are not anyhow promising that they will use those capacities at that point in time, but they are just checking that if the capacity would be used in some way, they are able to solve some potential issues later.
Thanks. And that also means that it's not additional non-costly remedial actions that are being considered in this process, in the individual validation. So you do, of course, in the individual validation compared to the remedial action optimization, consider costly remedial actions indeed, but also additional non-costly remedial actions or not?
Yes, there is the reason also that the individual validation serves, I mean, the reason for individual validation is operation security. So there could be some remedial action not, I mean, secured or saved just for the validation because they are essential for keeping the security. Second reason why there can be more remedial actions during the validation is that the validation takes place later in the process, and so TSO already have more information about the real availability of the remedial actions.
Thanks a lot. Let's move quickly to the next and last part.
Okay, so now I would like to just very briefly introduce you also some basics of the core flow-based intraday capacity calculation, because that's a calculation that is also being prepared in the core capacity calculation region. But I will not go in any detail. I will just show you the brief comparison. So in the core capacity calculation region, we are preparing also the intraday capacity calculation, which will be based on the flow-based principles and will use mostly the same capacity calculation tool as the day-ahead flow-based capacity calculation. There will be some simplification. For example, there will be no adjustment for minimum run, or LTA inclusion. And the capacities will be calculated 3 times per day. Firstly, there will be an update of the capacities at 15 o'clock in D-1. Then there will be a calculation at 10 o'clock in the evening, D-1. And then there will be a third calculation at 10 o'clock of the day of delivery. So this implementation will be gradual. So intraday capacity calculation will first start with the update at 15 o'clock. And then 1 year after the day ahead capacity calculation go live, there will be introduced the first computation at 10 o'clock in the evening, and then later on a computation at 10 o'clock during the day of delivery. Those capacity calculations will be then followed by intraday auctions, where the newly calculated capacity will be used, and then the rest of the capacities will be used in the single intraday continuous trading. But it's just for information, this is not the subject of our presentation. Just out of curiosity, this is how the intraday capacity calculation process will look like. So the basics are the same, but there are less boxes. So that's probably the message I would like to deliver to you. So the process will be simplified, but it will use the same principles as the core day ahead for this capacity calculation. Yeah, and I would like to firstly summarize this presentation before going to any questions. So to summarize the core flow-based day-ahead capacity calculation, I would like to say that it's a new regional, coordinated and harmonized process which aims at calculate precise, efficient, transparent and secure cross-zonal capacities for the core region, and those capacities will be used in the European single day-ahead market coupling. And it's very technical, complicated process to calculate these capacities. We use data which are available D-2. So all the data are predictions, which means that there is some in precision in the calculation, which is inherently there. And that the process also involves many people who participate in the calculation. The final results, the final cross-zonal capacities for day-ahead trading consist of 2 parts. It's the flow-based part and the LTA domain. The flow-based domain is the list of critical network elements, and for every element there is a remaining available margin, RAM, and a matrix of a PTEFs, the sensitivity factors. And then there is a second part of the final cross-zonal capacities, which are the LTA domains, which are the NTC-based values. And they have to be, or they will be used together in order to create the final cross-zonal capacities. And that's everything.
Yeah. Thanks again, Michael. I think the understanding is increasing because the number of questions is decreasing, so that's positive. There's at least 2 questions that are related somehow. It's about the decrease of the capacities after individual or during individual validation. And the question is, if the 70% increase is performed, or the obligations related to this, if you can decrease it, and actually the same question is somehow asked related to LTA. So I think this is something that can be should be easily be answerable. Yeah.
Yeah. So it's possible to decrease the capacities beyond the 70% requirement. So we can decrease it. So that we are not, in a way, not fulfilling the 70%, or we are not offering the 70%. But it's we are always have to provide enough capacity to cover the long-term allocations.
Yeah, thanks a lot. And again, also this individual validation process is strictly monitored. So it's, if you decrease it indeed, then you have to provide some justification to the NRAs. Yeah, thanks a lot.
Yeah, thank you. Thank you, Michael. Thank you, Adele. Thank all speakers and participants for the questions for this morning session. I think we absorbed a lot of information. Maybe it's good to explain that the slides and the presentation will be shared after the session on the ENTSO-E website. Answers to all the questions will be published in a document. Yes, we want to close now the morning session. In the afternoon, we will have a session dedicated in depth to publication and to transparency. So a lot of questions actually in the morning were about the subject. So most probably, most of them will be answered in the afternoon. So see you back then and have a nice lunch. Good afternoon, everybody. Welcome to the second part of the introduction workshop on core flow-based market coupling. And for this afternoon session, we have three speakers, Steve van Kampenhout, Said Rahman, and Marius Schrade. Steve, could you shortly introduce yourself?
Yes, of course. Good afternoon, everyone. Also, warm welcome on my behalf. I'm Steve van Kampenhout, working for Lta TSO. I'm in the markets department since almost 3 years now. And when I joined the market department, previously I was working on other departments in Lta. And since I started in the markets department, I've been joining also the core project. So looking forward to shed some more light here today on the transparency framework together with Said and Marius.
Thank you, Steve. Said, could you also shortly introduce yourself? You're mute, I suppose, Said.
That's correct. Thank you very much. Good afternoon, everyone. This is Said speaking from JAO. I've been working as a business analyst for about 4 years plus. And for the core flow-based market coupling project, I'm supporting with the development of the publication tool, working closely with the TSOs and developing it.
Okay, thank you. Marius, could you also shortly introduce yourself for the afternoon session?
Yes, of course. Hello, good afternoon, everyone. I'm Marius Schrade. I'm working for 50 Hertz, one of the German TSOs in Berlin, headquartered. And today we will go through together with to the KPI material and the transparency framework together with you. And I'm really looking forward to the session. Okay, thank you very much. To introduce some housekeeping things, could you please put up the slides again? Sorry for the disturbance. Yeah. We have possibilities of interaction. Of course, we cannot, with this huge crowd in the webinar, we cannot have voice conferences or discussions. So please, if you have any questions, also during the presentations, they will be collected if you submit them through the interface. It is also good to know that not all questions will be answered, but in the end, we will make a document with all questions and answers in them, and that will be published. There's also the possibility every now and then to where we ask you some questions through a Mentimeter system, but that will then pop up if needed. And it is also good to mention that this session will be recorded and will be published on the ENTSO-E website, as also the slides will also be published there. So that's for the practicalities. And now for the subjects in the afternoon session. Well, we are completely dedicated to transparency and data access. Well, to start off with that, we would like to ask you some questions in the with the Mentimeter to get a bit of a picture of who is, what are the opinions and what are the ideas in the crowd. Gert-Jan, could I switch to you?
Yeah, so maybe we can first show the login for the Menti. The code is also mentioned on this bar at the very top. Some people are already entered because this morning we also had this Menti meter live. So if you go to menti.com and use this code at the very top, then you can join the Menti. And then you can start submitting your your answers to the question about the publication platform and transparency. How extensively have you been analyzing available data from the core parallel run? Because we are, of course, curious to what extent this is something you are analyzing. It takes a while before the responses are there because there's a small time lag between what we are broadcasting here and what you receive. But we now see the first votes already coming in. So at least there's at least one person that did not know the data existed. So that's will be definitely helpful because I think there's quite a lot of elaborate information on the location of the information, but also what kind of information is published as well. And as said by Ruud before, also the questions will be hopefully either answered here or answered after the webinar. So also quite some people that maybe are aware of the data but didn't really use it. And there are also people already processing the data automatically. So that's also helpful to hear because that's also something that is enabled, automatic connection to be able to fetch the data. Also people that now and then check the results. At least what we see is that the results are being more checked and more questions are asked, which is of course perfectly fine for us. So please, if you did not do so, you can of course continue with the putting your answers to this, because for us it gives again additional insight. Then maybe on the next question, that's on the publication platform, of course, again. And it's what type of analysis do you perform based on the publication platform? That's because of course we provide the data and based on the previous votes and answers. It's a pity that this is the first answer, but let's see if there are more votes coming in. Now, based on the previous answer, we saw that several people are using this data already. But then, of course, the question is for what kind of users you can and user are using this. So we see price forecast, market analysis. So now we see the answers dripping in. Price forecast again. Let's see what comes in. Market analysis. Maybe people don't want to share exactly for the purposes they are using the data for strategic purposes. Connect analysis, it's something that can indeed be done. I can imagine this. People also are just curious about maybe not knowing exactly what they will do with the data, but at least having access to this. Capacities, of course, definitely I can imagine this. RAM, so what kind of capacities are available. So capacities, RAM, those are a little bit the same. Plausibility check, probably on capacities that people have in mind. Spot forecast, so again also the forecasting, price forecasting, spot forecasting, market analysis. Good, I think we, as said, please still put your votes in and then maybe we can continue to the last final question. How satisfied are you with? This is not the right question. I think this was the
this was the second question of the yeah.
Okay. Yeah. As said, please continue with the votes, and then maybe we can start with. There is at least a lot of people for which the data is new, or they don't know exactly where to find it, and that's I think the best bridge towards Steve and the presentation, because that will give some insights.
All right. Let's get started.
You can see my screen.
Can the presentation? Yeah. Okay. So, very high-level introduction, because of course we've debated already transparency a couple of times in the past with the core consultative group participants. I'm sure a lot of you, some of you are also taking part in these discussions. As you know, if you've seen this information before, there is an exhaustive set of requirements in terms of publication coming from the core CCM. This is our legal basis. So this will always be the foundation of the solutions that we put forward. And we started also in these discussions adding some additional, let's say, needs requirements that surfaced during these alignments in 2020 by publishing information which is not strictly required by the core CCM, but which has proven to be useful for market participants working in the past or even today still with Cbco data. And on top of that, we felt it would be welcomed and beneficial if amongst TSOs we've made an effort to harmonize the way how we name our grid elements, which you will then see later on in this presentation coming back in terms of what we call connects and remedial actions. So these three elements, I would say, have scoped the solutions we have implemented. And in terms of tools, solutions that are accessible on JAO, there is already quite a lot for you to explore. The key focus today will be on, at one hand side, the publication tool. We will go a bit in a demo mode where Syed will show you live how the publication tool works. On this publication tool, there is a daily publication of information. So every time that we run a new business day, and it's each day we run a new business day, the information in this tool is updated. And then we also have a very interesting process of monthly KPI reporting. So this is exactly the same information that we send to the NOAs that we also publish publicly for you, for your usage. And Marius will zoom into those KPI reports in the second part of today's session. The third component, I'm only going to briefly mention it here on the introductory slide, as more information will be given in next week's core CG meeting. That's on the static grid model, which we are going to publish every 6 months in a harmonized Excel format. So if you are curious to learn a bit more what that all compromises and have more detailed questions, then please make sure you can also join next week's core CG meeting. So that in terms of introduction, let's start by having a look at the publication tool. So generally, it's a website-based solution for which you can also, through web services, access the data, or to a GUI. Then you have both options. Of course, it's not the first experience that TSOs and JAO have with such a tool. We already have the utility tool in CWE up and running for quite a lot of years. But it's fair to say that it's not the perfect tool, and that we have learned from this first experience by improving what we delivered in CWE, improving it for core. The main functionalities that you will see is it's quite powerful in terms of accessing data, searching data, downloading data, either manually or through web services, as I mentioned. And we started using this tool structurally for publishing data around the end of last year. It was around the Christmas period that we had a stable version, and that also from a TSO side, the Parallel Run was moving to a next phase where we started progressively publishing these business days, these results. Since then, left and right, some improvements have been made to the tool. Also quite recently, some additional information has been deployed to the test environment, like remedial actions, which are being used by the NRL. If you remember this morning session, with the optimization of remedial actions. Now we also will have a screen showing you which remedial actions were optimized. So that's quite recent developments that were made, and there are still a few more in the pipeline. Towards end of year, the objective is to be able to release post-coupling data. So there we're talking about the intraday ATCs, which are there, the net positions, the prices that result from the market coupling, which now you can already access via the weekly shared CSV files, but end of year they will also be available on a daily basis in this publication platform. And beginning of next year, there will be a monitoring layer added on top of the publication tool that will make it clear how the, let's call it, data completeness status is. So if there would be some data missing as part of the process, then this would become much more clear thanks to this new functionality. There is one question mark still a bit on this timeline on the bottom, where we need to further align amongst TSOs and JAO by when exactly we can implement it. And that's about changing one specific page, the core market view, to accommodate this new way of doing LTA inclusion, which you probably have heard this morning how this works. And now we still need to put it into the publication tool as well. As soon as we have a date, we can, of course, communicate that to you. So we will now go through the different pages of the publication tool in the following format. I will quickly recap where we are in the process, say a few words that are of importance for the pages in relation to this process step. And there is always a slide with a screenshot. I will not talk you all the way to a screenshot. Instead, what will happen is that we will then go live into the publication tool where Syed will, with live data, talk you through these pages. So in the very first step of the process, the first step after TSOs had delivered input data to the core CC tool, in the very first step thereafter, there is a merging activity that takes place by RSCs. And this is just using individual grid model data that has been sent in by TSOs. And the underlying assumptions of these grid models, meaning which are the loads, the productions, net positions that have been used, as well as what are the reference amount of exchanges on bidding zone borders external to the core CCR. All this information is in its totality, when you look at its totality, is spread out over the 3 pages mentioned here on the screen, the D2CF page, the RefProc page, and the reference net position page. So as a small recap, the merging will take the individual grid models and it will link them together against a reference net position to achieve. And then those are just the different informations displayed. So I move to the next slide. You see some introductory screenshots, as I told, that contain IGM assumptions, exchanges of the borders external to the core region, and also the net positions of the hubs, of the non-core hubs. So maybe this is now a good moment to try out opening the publication tool.
Perfect. Thank you, Gertjan. So as an example, we'll take the business day 19th of November, and we can start with the 2-day head congestion forecast, so the D2CF page. as Steve just explained, here on the left-hand side, you could see the vertical load, generation, and net position per hub. And on the right side of the screen, you will see the same information, but per TSO, same data per TSO. You're also able to download this data through the download functionality, which is on the top right section of the screen. And you have the options to download this as an XML or CSV for a select amount of positions or for the full day as is convenient for you. Next, we can go to the RefProg page, which is just one below. So here the idea is the same. You have the data published and available. Also, you can download this completely. It's also, of course, as Steve has mentioned, you have web services. So this data can be also retrieved via API as well. We can then maybe continue to the reference at position. And again, the same idea. You have all the data published, available to you, and of course, retrievable via download as an XML or CSV. Or additionally, you can choose to use API and use that in lieu of the website. Back to Steve, I guess.
Yeah, let's switch back to the presentation, please. All right. So once the merging is completed and an initial calculation has been performed, and we'll come back to that initial calculation with flow-based domains. We come back to that in a bit. We have the non-costly remedial action optimizer, NRAO, as we like to name it. And this NRAO can use both topological PSTs, different type of remedial actions, as preventive and curative setting in an attempt to optimize, to increase the available capacity on the CNEC, which has the lowest capacity available. And the remedial actions that the NRAO has chosen for each MTU, for each hour in each day, those are then displayed in the respective pages. And what's interesting to ease the data processing is that we aligned on what are, how to name those remedial actions. So we will see it in a bit. When you see PST in the name, it means it's a PST action. When you see topological name, it's topological action. And we've also applied the same naming convention into the publication of the grid models that will happen on a biannual basis, so that you're able to find your way back throughout these different tools that we use for creating transparency. Now, if I move to this next slide, then here you will see the naming conventions that we've agreed for these remedial actions. So nothing has changed compared to when we aligned on those with you throughout 2020. Just here a small recap with examples that help to get us into the same, in the right mindset. So quickly talk you through it. We have a first category called topological remedial actions that follow the syntax as seen on the screen. It starts with TOP and then an underscore, and afterwards the functionality of the action, opening a line, closing a line, splitting nodes, substation, bus bar into multiple nodes. Then you will see the number of nodes appearing in the naming. And then, of course, the substations or the line between the substations to identify which part of the grid we are talking about. So then you can see, as you saw example coming out, if we let's take the first row. If we open a line between Mercator and Horta, which are two substations in the Belgian grid, then this will display as TOP open Mercator Horta with also the element identifier of that line in the grid model. Second category, complex action. That name says itself, it's a bit more complex in terms of what are the actions in the grid model that this remedial action represents. And you will then see it back in the name by seeing the prefix complex in it. And there it's going to be a bit more described in the publication handbook accommodating the static grid model, what this remedial action is doing, because it's interplaying between different substations, and the substations are given by their name, but what exactly it then does needs to be described a bit more in detail. PST tabs, we'll definitely see these examples when we go to the publication tool. That's quite straightforward, starting with PST in the name, then the name of the substation we are talking about. And in case a substation has multiple PSTs, then we have an enumeration for the PST, the individual PST we are looking at. Finally, we have some miscellaneous remedial actions, meaning there are only very few of these. Nevertheless, we also agreed on how to give them a name. We have special protection schemes that start with the prefix SPS in the naming. And then we have some transformers with angle regulation along the Polish border, and these start with AT as a prefix in their name. I think that's enough in terms of theory. So again, I'll ask Syed to take over the screen and show you these examples in the publication tool.
Thank you, Steve. So Gertien, I would ask you to then open the remedial actions. We can start off with preventative for business day 19th of November. And here I would like to highlight that you're able to toggle through the different hours. So there's an arrow key on the left and right hand side of the date picker, the hour picker. And so if you can click on that, you're able to then check the different positions. Now we could move to the curative actions, so the next page. So here, I think, Gertien, you have to go to hour 5. I think we have some data published there. There we go. Here you could also see how it's looking like. We also have some examples of the topological actions, if I'm not mistaken, for the October 29th, but we can go there shortly after we have a look at this page. So 29th, October. And I think it's for the remedial actions preventative page. And you can go to the hour from 9, 10, and 11. So I think you could see here, if I'm not mistaken, the bottom, the topological actions.
So what we see here for the PSTs, to add some more, shed some more light, is the change in tab positions that the NRAO applies. So the baseline, this is a tab position before NRAO, and then the last column represents the number of tabs after the NRAO. This is particular type of information related to PSTs, and hence this will only be filled in for PSTs. When we talk about topological media actions, these fields will be blank on the screen.
Additionally, I can also inform you that the positions where there are no optimizations applied, for example, on the 18th of November, Gertien, if you could go to our 18 to 19. Yep, we just cross it. Yeah, it says that that, yeah, exactly. That there's no optimizations applied as well. That was, yeah, the. So that was video last page.
Which one? The curative or
Preventative
prevent?
for 18th November.
Yes.
Hour 18 to 19.
18 to 19.
Yes, right. It's not clear for me, but I think it says that it wasn't applied.
Yes, given hour was not optimized in NROW, it says, yeah.
Correct, yes. So I just wanted to also display example of that as well. I think we can continue and go back to Steve.
Yes. A last page before we go into a first Q&A are the validation reductions. I think it's quite a looked page at quite some interesting data. So what this page displays is the outcome of the validation step. So as you've been hearing this morning, the TSOs have a responsibility to evaluate if the capacities coming out of the intermediate flow-based computation, so after NRAO has worked, after we have added the virtual capacity to secure the minimum capacity targets and to secure the long-term allocated capacities, if all the areas of the domain are safe. And if individual validation concludes that it's an unsecure capacity, then there will be a capacity reduction to make it secure again. The resulting result is what we call an IVA, an individual validation adjustment, and it reflects on the particular network element with how much the capacity had to be reduced on network element to make it secure. Now, I explained this is an individual validation for the German TSOs together with Austrian and Dutch TSOs. They run this individual validation with a common tooling and with a common result. So there is already a level of coordination embedded in these IVAs, so to say. And then, as it is a local process, as with any process, sometimes it can go wrong, and we need to have a fallback strategy in place. And in order to be transparent on what this fallback strategy is, there is also on the Chow page a publication in terms of assumptions that TSOs apply for this parallel run. When you open it, you will see also the assumptions in terms of capacities that people apply when they encounter a fallback. And in order to make the link, when you look at the results on the validation reductions, a best practice amongst TSOs is to indicate this as part of the justification field. And then you will see the word like failure or fallback applied. And this typically then leads to a higher than average application of IVA. This again would be a good moment to go to the publication tool.
Yes, indeed. So, for example, yes. Perfect. Here you can see the publication for the validation reduction with the connect names, the TSO names, the IVA, and the justification. And also on this page, you have pagination as well. So sometimes at times you would have to, not all the data is visible on the first screen. So you would need to then go through all the pages to be able to view all the data that is published.
Sorry, just
Okay. Switch back to Steve.
Yep. This should be our first Q&A moment, if I'm not mistaken. Voila, here it is. So if there are, I'm not in the other setup, so if there are already questions, maybe that have been raised there in the chat, or people want to ask them now.
Yeah, no, definitely
let's
questions. Questions have been raised. One question is for the Java publication tool: is there API provided for download? And I think the answer is yes, but there's also a question on where this can be found. This the instructions on API.
Yes, indeed. If you go to the core parallel run link and type /API at the end, you are able to. There's a GUI actually there available to support you to see how you can test your code and see how the data is retrieved. So that way you can actually, start using that to retrieve that information. Maybe this is something we can provide afterwards as well, the link, or share it now somehow.
Maybe good to show on the website. Can you shortly repeat, and then I will show where it can be found?
Yes, just this same publication tool. If you go back to the core parallel publication tool and just put /API at the end.
Okay, so here it's, and then you say /API.
Here you're able to toggle through the different pages and test your request and see if it's working fine. And then, of course, you can go ahead and implement that to retrieve the data.
Good. Then there is also a question on the prices. Where are the prices stored for the parallel run? And that's maybe also something that we can show again on the website, because the prices are not already shown in the publication tool, because we are in a parallel run. So they are stored separately. So we will show you in a bit. So again, you have the web page of JAW, where the publication tool is also there. And if you scroll down, then all the results from the market coupling simulations are being stored below this. And you can also download this again as one, you can probably one zip with all the separate CSV files. So that's for your information. Then another question: will the data structures be identical between parallel run tool and a final production tool? I think the answer is yes, Syed, right? So what we are now seeing in the publication tool is actually something that will remain at Go Live. The only thing that will change is that more data will be available, also the post-coupling data, and also that the data will, of course, be based on production data. And there was also a question on the information that is still missing. Prices, I think we just explained, but also LTN and net positions. And I think normally this has already been answered by Steve, I think, in the presentation on some information that is still missing, and that will be published at a later stage.
The LTNs are already being published, actually, on the publication tool.
Okay, so LTN and net positions, I think, also. But in the presentation, what is missing is displayed, right? So that's maybe for the people that are present. We have some information on what is still to be done, but the rest should be available. Right?
Yeah, exactly.
Good. There's also a question: is the initial D-2 flow-based domain published, and this is indeed published. I think it's one of the pages that we
next slides.
Yeah. So that will be covered. And there's also a question on the CNEX and MNEX, but I think this is also something that we still need to present. So then we can have a look maybe at that as well, how you can recognize them. Yeah. Okay, then maybe better now to continue, and then the other questions can be answered maybe at the place where we are presenting this. Yeah. Okay.
All right. So moving forward, we come to exactly the publication of flow-based domains. We have several moments in the process where we calculate a flow-based domain. So the first one that we publish, that's the initial flow-based domain computation. So that's the one being created in D-2, and as the very first one being used also to calculate initially PTDFs and then filter out connects based on this 5% filtering rule. And this is a nice example of a best practice that we did in the past in CWE. Wasn't an official requirement in the core CCM, but after alignment in core CG, we decided to take it on board and also publish this information. Towards the end of the process, we have two domains that you see highlighted on the right-hand side of the process chart, the pre-final flow-based domain and the final flow-based domain, which have to be published no later than 8 o'clock, respectively 10:30, D-1. All these pages have the same structure. There are three main sections: information on the CNE, the discrete element under consideration, the information on the contingency, because in a flow-based language, we always speak about connects. It's the combination of a CNE and a contingency. And then for this connect, the breakdown of the RAM as per the lengthy list of requirements of the core CCM. We will see that in a bit, including the PTDF parameters. Now, what is nice to know about the breakdown of the RAM, and that's a gimmick that we added in recently, is that we've also now display what is the target in alignment with the Clean Energy Package Minimum Capacity Regulation. What is a target to be achieved on each connect? And this can be the 70% or action plan or derogation value, whatever is applicable on a per TSO per country basis. This attribute, which we call the RAMR in core CCM, this describes this target. And as a reminder, this represents the totality of all the markets exchanges, including the non-core exchanges. So it's core and non-core exchanges together. And then we have a second attribute, which we have labeled the minimum target in core. This is the RAM, as you've seen this morning, explained to this morning. And this then describes the capacity which is then available in Euphemia for core exchanges. Simply, you can then deduce the relationship between these two attributes as the difference being equal to the non-core exchanges. One last thing wanted to point out here is that in the initial flow-based computation, there are some parameters shown on the screen empty because they are not yet applicable, not yet relevant at that stage in the process. For example, the flow induced by the NRAO, we have not yet run an NRAO at that stage. The virtual capacity, AMR, etc., the IVAS, all these future process steps related breakdown is not yet applicable when we are in the initial computation. Then we are at, maybe I should go one slide back. Yeah, here. This is what I wanted to still show. As for the remedial actions, we also have a naming convention for the connects. So both for the section of CNE and contingency, you see this series of attributes that we publish to identify them and to be able to retrieve them back from also a grid modeling perspective. We go about EIC codes, about the hubs, so the countries between which these connects are located, the substations, the type of the element you are looking at. Is it a PST? Is it a transformer? Is it a line, a tie line? The concerned TSO, and also the direction of the connect. because you can look at a connect in both directions when you look at the two substations from A to B or from B to A. And for the element publication name, there we have this naming convention that we apply. It's shown on the right-hand side of the screen. When it's a line, we display the name of the line and the identifier if the line has an identifier. And mostly this name of the line is using the two substations which it connects. When it concerns a PST, the PST will be put as prefix in the name itself, just like we did with remedial actions. And then we have some specific cases, lines that we call tripod lines, so that it can have a connection in the middle of the line towards a substation transformer behind it. So we can have multiple line sections described in such a case, and these cases are marked with the character Y as a prefix character, and this Y then represents the node which is connecting the different branches of the tripod, with the first mentioned substation after the Y actually defining the branch of a tripod which is being monitored in that specific row in the publication tool. So with that being said, we can again open the publication tool to make this come alive.
Yes, indeed. So we can first look at the pre-final computation page for, let's take same business date, 19th of November. And here, of course, as Steve mentioned, on the left-hand side of the screen, the first section, it contains the information on CNE. So you have, of course, the TSO name, CNE name, the IC code, direction, hub from hub 2, substation from substation 2, element type, and Fmax type. Thereafter, the middle section displays information on contingency. So of course, here you have the TSO name, contingency name, branch name, EIC code, hub from and to, substation from and to, and element type. And lastly, on the right-hand side of the screen, you have the breakdown of the round. Here, I also would like to highlight that in the domain pages, we have filtering functionality. So if there are some relevant data that you would like to filter for, that is possible. So as an example, I will ask our team to maybe just click on the search button on the top left. And here you're able to filter on different parameters, whether it's a CNE name, which is a text input, or you can select a TSO name through a drop-down pick list. Additionally, you have the hub from and hub to. The contingency, which is also text field, so you can input if you're aware of that. And of course, you can select if it's pre-solved, true or false. As an example, we can maybe select TSO. For example, let's select Avir. Maybe and just see if, how that plays out. And just search after that. And then you get the filtered results for that TSO. You can, of course, also reset the filters if you have multiple filters there, which then returns you back to the main page. And of course, that's how, if you would like to try another one, we could draw a hub from. Possibly you could choose Belgium, maybe BE, just to on the west side and see how that plays out. Of course, then you get the results that you are filtering for. So the results you're filtering for at the moment cannot be downloaded as you see them. They're just available on the GUI. But of course, this is something that is, of course, we think useful for the users to be able to play around with the data. Next, we can also look at the final computation page, which is very similar in layout. So it's the same layout. You have the filtering functionality as well. And of course, as mentioned, pagination. So here you can see there are 10 pages. So not all data is present on the first page. And you're able to go through all the data, through all the different pages. You can, of course, retrieve this data via an API, or of course, download it via the download button through the GUI as an XML or CSV for the desired time frame. I think we can then move back to Steve. Continue the next slide.
Yes, I believe there was also a question from the previous session on Connects versus MNEX, if I remember well. Now, we do not publish MNEX, so there is no filtering there to apply. The publication requirements are straightforwardly pointing at the Connects. So as soon as we start publishing a flow-based domain, we already are only speaking about connects that are kept after this initial 5% PTDF filtering. I think the only, let's say, segregation parameter in the list of connects is you can see whether these connects have been pre-solved or not. So whether these connects form the boundaries of the flow-based domain or whether these are redundant connects compared to these boundaries. And this is included as the to the attribute pre-solved that you can use. All right, we can go back to the presentation, please. Yep. So extended LTA inclusion. I'm sure that you spent some words on it in the morning session. So since 2 months now, since mid-September, we have switched to this new way of doing LTA inclusion, which entails that we send no longer only a flow-based domain to a FEMIA, to simulation facility, but that we send both a flow-based domain without LTAs and then a set of bilateral exchange restrictions representing the LTAs as two distinct inputs. And in relation to that, it's important to underline that if you want to see and know what are the capacities TSOs have sent, that you no longer only have to look at the page final flow-based computation, but you also have to look at the page final bilateral exchange restrictions. And when you are in a normal operation of the process, of capacity calculation process, this final bilateral exchange restrictions page displays, simply said, the LTA values, the long-term allocated values. As we are in a final stage of the process, these values always shifted with the long-term nominations where it is applicable. So that's why you will see quite a correlation between the LTA page and the final BEX page. Now, when we are in the process of fallback, so when the capacity calculation tool did not succeed in producing normal capacity results, then we activate default flow-based parameters. And in case these default flow-based parameters are active, then what we find back in the final BEX restrictions page are these LTA capacities where on top of the long-term allocated, there can be some adjustments made. So in this case, it can be that these capacities that you will see are a bit higher than when in normal operation that these represent the LTA domain. We'll also come to it a bit later, but since I'm speaking about it now, I can already mention it. There is also a page in the publication tool that allows you to transparently detect for which calculations, so pre-final, final, initial, for which days, which hours, DFPs, and spanning were applied during the calculation. So that helps to identify which were these, a bit fallback hours, so to say. Moving on to this page, these are the screenshots showing the final backs and the LTAs. As usual, let's have a quick look at the publication tool to have a bit of a better view how these play out.
So Gertin, I would ask you to maybe go to business day 9th of October, because we have EFPs created with the backup tool, so we can check the publication for the final bilateral exchange restrictions page.
It's selected.
There we go. Here we are. And here you can see the values. And of course, as Steve mentioned, we also have a page called the spanning DFP, spanning the full-based parameters, which I would ask Gertin to also maybe display, which shows, of course, positions. I think that's that for these two pages. We can then continue back with Steve.
Yeah, I believe it's time again for a Q&A window.
Yeah. No, indeed. Many questions popping up, so that's good. There's one question: is there documentation explaining which each column represents? And I think there is. There's the publication handbook. So maybe it's something that we can also show a little bit later on the web page. So in the publication tool, actually, I think at the home page. So if you go home, if I'm not sure if it's already be able to show it. Yeah, it's on the screen right now. So I'm going back to the publication tool, clicking here, so that it goes to the home page. And then on the right, you have the publication handbook. And there you can download the publication handbook with all information about what is being published. Then another question about when the data is being published. So maybe Steve or Syed can help me here, but it's indeed done daily, and we are now in external parallel run working with a few hours delay compared to the future operational process. Indeed, it should be available around the same time, but I don't know when exactly. So maybe Syed or Steve can help me. What can market participants expect when the data is available?
Yes, I think right now we're a few hours delayed, but generally when we go to production, it's as per the normal production timings. There's not a large amount of delay before the data is available.
Yeah, and today indeed, so it's normally 4 hours delayed. Indeed, so that means that at the around the end of the afternoon, then normally the data should be available from that specific business day.
Yes.
Okay. And then it's a question: is it possible to download only data for connects of selected TSOs, not all connects, so that you do a pre-selection in the search, and whether you can download that selection then?
Well, via the GUI, that's not possible.
Yeah.
So what you filter for in the GUI, you're not able to download that directly. So you would have to download the full set and then filter from the XML or CSV that you download. Yeah.
Okay. So that indeed. Clear. And there's a question on, is there somewhere on the JAW webpage a list of substations and its approximate GPS coordinates? The answer is no, not in the publication tool. But what is foreseen is so-called publication of static grid model. Maybe Steve, you can correct me. I don't think it's containing GPS coordinates, but it is containing the different descriptions of the lines being used, of the physical lines. So the reference to IEC codes, for example, and also some characteristics of those lines. And that is something that will be published earliest 3 months or latest 3 months before go live. I don't know if you want to complement something, Steve.
Don't know by heart about GPS coordinates, but it will be presented next week in Core CG.
Yeah. So that is.
Those interested.
Yeah. Thanks a lot. And then a question: will the alpha parameter from the Ballast formulation be published? I think the answer is no, but maybe Steve, you know for sure.
That's not foreseen to be published, indeed.
Indeed. And then there were 2 questions. Are files sent by TSOs for capacity calculation process available for market participants? And also another question, will Marketplace get access to all necessary data and grid models to be able to make own predictions and cross-zonal capacities? And I think the answer is a little bit what is presented today that's available in the publication and transparent to all market parties. Next to this, indeed, the static grid model, which I just referred to. And indeed, the expectation that this is at least the transparency that can and will be given today, and that should be enough for market participants to perform the analysis that they maybe want to do. And that's at least something that is fully aligned as well with the regulatory framework, of course, as I think Steve also presented in the beginning. And then maybe for Steve, it says, is it possible to do a mapping between net positions and capacity domain from the information available at the JAO website? So what they are asking, is it possible to calculate from cross-zonal transactions from the net positions and the PTDFs? I don't know if
Yeah, so we have a market coupling result delivering net positions. We have PTDFs explaining how each potential cross-zonal trade would make use of capacities resulting to net position, but there are multiple combinations possible. So I don't think that you can deduce a unique set of exchanges to come back to the net position outcome. Can be multiple situations.
Yeah. Good. And then Syed, also a question maybe, where could we track when each of this data is updated? So is it also possible to track at what time exactly the data was published?
Yes, this is a question that popped up earlier as well, and we will develop a new API node. Is the data available or is there new data? So the MPs can then connect to that and check, and this will then inform them if there's any new data that's available, and this can inform them right away.
Okay, so this is something that will be available in the future, right? And that's maybe linked to the roadmap that was presented in the beginning. Yeah. Okay, more content question. Maybe what is the difference between, for Steve, maybe what is the difference between max exchanges, max backs, and final bilateral exchanges restrictions?
So the final bilateral exchange restrictions describe a part of the capacity, namely the Lta part of the capacity, which is made available for the market coupling algorithm. And using those capacities together with the flow-based domain, which describes the other input, you can obtain different market coupling results. And the max backs view, we will come to that later, the max backs view is saying, what is the maximum amount, or what is the maximum net position, maximum amount of exchanges that you can retrieve if you focus yourself on one particular hub, one particular border. We will come to that a bit later on in the slides as well, when we go into these definitions. So one is input, and the other one is how you use this input to create a result.
Okay, clear. Thanks a lot. Then there are 2 questions still. One, is there a reason to the choice of data published in parallel run? and they make the comparison to the introduction of Allegro, where the situation with and without Allegro included was simulated and published, these results. So that was in CDB, where flow-based is already implemented. And I think the answer is mainly that, of course, core is a new region. So this is something that is completely new, and the choice has been made to make that what is done in the parallel run as close as possible to the actual operational situation. And that's indeed also the reason why there are not all kinds of scenarios with or without it, because it's a new situation that we want to provide insight to the market participants. So that's maybe the answer on to that question. And final question that at least I could see until now is related to the when all the information is digested and there are remaining questions, where can they be posted? And it will also be at the end of the meeting, but it is possible to post it on a so-called Q&A forum, where also the questions will be dealt with. So if there are in the future remaining questions, then this is something that can be posted there. I think we can move to the next part of the presentation. Steve.
Yes, indeed. I'll go one slide back. So we've tackled the, let's say, the biggest part of the process. So now we have a series of pages that highlight particular outcomes of a process, or where the publication tool acts to transfer information to Euphemia. First series of info is in relation to ATC capacities. So these are capacities on borders external to core, but also on the Allegro internal DC border in core, where the ATC capacities are the constraints that Euphemia needs to know when it tries to allocate the capacities. And then for those borders where TSOs use core processes to transfer this information is displayed in the core CC tool. On shadow auction ATCs, that is in case there would be decoupling, partial decoupling happening during the allocation step, then we need to have capacities in place to facilitate a fallback procedure with. This fallback procedure is running shadow auctions. And as on this page, you will find the shadow auction capacities that are being computed alongside with the regular capacities.
Yes, and we can maybe quickly show these pages are looking at the publication tool. Yes, we can continue to check the 19th of November shadow auction ETC. Here we go. So pretty standard, same layout as most of the pages. We have all the ETC values per border in the direction. And of course, we can also check the ATC page, where at the moment we're publishing the ATCs for the BEDE Allegro border. The remaining borders will of course be published shortly as well. Okay, can I think go back to Steve so they can continue with the next slide.
Yes, very interesting info for you as well. We do not only publish the Connect capacities, we also have in the core CCM possibility to work with allocation constraints. Maybe a little word on terminology, because a lot of times these allocation constraints are also referred to as external constraints and vice versa. So technically, it's the same reasoning behind it, why there is a constraint on the net position of a core hub. There is just a minor nuance in whether you look at the SDAC net position of a hub or you look at the core net position of a hub when you express the limitation that there is a limitation in terms of amount of simultaneous import or export that can happen. And when you express it as a net position, as a limitation on a core net position, then we will find it back in the flow-based domain page. When you express it as a limitation on the SDAC net position, we'll find this back in a separate page called the allocation constraints. And it's on this allocation constraint page that the Polish TSO and the Belgian TSO, you can see there the import limits which are being used for the allocation. I'll go one slide further. Yeah. And then on the external constraints page, these are being used by the Dutch TSO. And yeah, these can be found back in the domain page. You will see the word external being part of their name, of the CNE name. Now, I do need to point out that there's also some external constraints in relation to the Allego interconnector that pop up if you search for this word external. They do not represent a typical, let's say, import-export limit for technical reasons related to grid conditions. These are purely there because technically the implementation of a DC interconnector works with what we call virtual hubs. And for the whole algorithm to run correctly, you need to say also on these virtual hubs what the size, the capacity of the interconnector is. So that's why this value of 1000 megawatt is also coming back here, described as external constraints on the respective Belgian and German virtual hubs associated to the Allego interconnector. So maybe we can quickly go to the publication tool to show that allocation constraints page.
Indeed. Here we are. So, as Steve explained it, you can view the external constraints, allocation constraints, with Belgian and Polish.
Okay.
Yeah.
Then we can move on.
Indeed.
Back to the presentation. Yeah. And now we come to the slide where we explain this maximum possible lateral exchanges between each border. It's also called the max BEX. And the maximum core net positions that each core hub can achieve. We have these displayed both in a table format on the respective pages called max exchanges and max net positions. And so this is where if we take a theoretical situation where we try to maximize the let's say the net position of a hub, or we try to maximize exchanges on a certain border, then this is like the value that will come out of it. So it's like kind of the extreme value that can be obtained from the available capacities. We display them, as I said, in a table format and also graphically on the pages called core map and core market graphs. And how do we achieve, maybe it was the initial question, how can we achieve technically these maximum bilateral exchanges? It's by assuming that we look at only the two hubs that are connected by the border and putting net positions on the other hubs to 0. And this brings us also to a specific requirement of the core CCM to give the market participants a tool to evaluate exactly the interaction between exchanges and capacities. We have developed a page for that in the core market view page. We'll directly demo how it works. We'll see there are different sections in this page where we can check the volume of commercial trades. As users, you can enter these volumes to check the feasibility, both from an exchange point of view as well as from a netto position point of view. And basically, the publication tool will use the standard formulas that also apply in allocation to check for each of the RAMs available on each connect. Is the sum of the PTDF times these exchanges still respecting the available RAM? And when it's not the case, then you have reduced more capacity that's available. That's not possible, and you will see then these red flags popping up, meaning that these trades are infeasible. And this is still the point, as I mentioned during the introduction, that we need to make an adaptation upon to switch to this new reality of extended LTA inclusion, because we're not only checking against the flow-based domain, we also need to check against the final bilateral exchange restrictions. Voila. I think that this series of pages indeed are listed here in the presentation. And let's have a look at the publication tool, do a little demo that will make it more clear.
So indeed, here you have the market view page. So on the right-hand side, you can see the max volume. This is coming from the max. So the bottom was the max net positions for the export and import, and for the max volume is coming from the max X, of course. And in the check volume here, you can, of course, input your volume trade. For example, we can just put a random number just to see how the direction would be, and click to test, and the gray box right adjacent to it, and it would then, of course, apply the formula and return back a result. It's constrained or not. And below, if you scroll down, you will have of course, the hub-to-hub positions. So here, the first test is to ensure that it's equals to 0. So if you put in, for example, 400, it will be constrained. But if you put, again, minus 400 for a different hub, then that is then okay. And then the next test is, of course, as Steve explained it, it will check again if the trades are feasible.
So this is a very simple example playing with 2 hubs, 1 border. You can, of course, map an entire trades schedule situation in this screen to see, for example, this was the result in CWE. If I try to exchange a bit more on a certain border, is that still feasible or not for the same business day? That's the idea behind it. And so when we look at the left-hand side, there are other screens like the maps that visualize this. Voila. So for the specific business day, specific hour, on this map, you get an overview of what are the max net positions and max bilateral exchanges. We keep that notion in mind that it's every time an individual optimization. So it's not that this total set of values is at the same time feasible. It's always individual optimization which is displayed here behind. And then you have the same information in format on the max backs page.
It's just under the final computation, max net position and max specs. There's also the core market graphs. I'm not sure if you touched upon that, but that also displays the maximum viable exchanges per hub. And of course, you can also compare different hubs as well. Okay, then I think we can continue with.
Yeah, with the last part of the application tool presentation. Yeah, the question popped up before. There are still pages missing data. Indeed, we still need to release some of the post-coupling pages that then will show shadow prices, the allocated capacities, intraday ATCs, and that will then also start including the market prices and coordinate positions, which are now embedded in the CSVs, also in the publication tool itself. So yeah, that's a series of pages which are already in the list of the publication tool, but not yet showing them data. So this is supposed to come by end of year. And then there is one page called Border Data Overview. That's a page that we kept from CWE, where it regroups border relevant information being displayed over other pages. The ATCs, shadow auction ATCs, LTNs if applicable, allocated capacities, price spread, just grouping it together from a border perspective. And yeah, it's also using post-coupling data. So for the moment, there are still blank columns in there. And by end of year, this then will also start to be filled in. I think let's see where we are. Yeah, so you had to find back the click. Last info I wanted to share is what happens when we use the backup tool. So maybe a short word on the backup tool. There, we do have, of course, our main tool to calculate this whole process, the CCT, the core capacity calculation tool. In the case that there is a critical issue with the tool and it cannot be resolved on time, then we still need to be able to execute the pre-coupling process to deliver capacities. And that is the role of the backup tool, so that we do not get stuck. Now, this backup tool is, when it's used, giving a limited set of information to be published. It's not like a full exhaustive set, and the reason for that is that when you use the backup tool, the resulting set of capacities are the default flow-based parameters. And as we've saw a few minutes ago, when we apply default flow-based parameters, you will see this in this page called spanning DFP. So we'll know for which days, hours, it was applied, default flow-based parameters, and the relevant capacity in that case is represented by that page, final bilateral exchange restrictions. information which is also still taken on board are allocation constraints, of course, and the LTNs which have made the shift for long-term nominations. So I think in terms of pages, we've covered it all. On the side, maybe it's still worthwhile to show the post-coupling pages and that border overview page.
Yes, we can check the net position and the intraday ATC pages. It's on the test environment, so not yet deployed to the Coral parallel environment. But as Gatien has pulled it up, so here we can see the net positions, core net positions. And for the intraday ATC page, we can check the 21st of October, if I'm not mistaken. There we have the intraday ATCs published with the leftover capacity as the initial ATC. It's the 21st of October. Yeah. There we go. Yeah.
Good.
So check the border data overview, maybe just briefly, just to see how that layout looks, although it's not fully populated.
Which one, sorry, Syed?
The border data overview. It's the, I think, the fourth page. Just to display how the layout would be. So you would have the different borders and then an aggregate or compilation of all the different values, ATCs, schedule exchanges, condition income, LTNs, that auction ATC, so on and so forth.
Yeah.
Oh. So more to come. Yes.
Thanks a lot. Maybe because there are still some questions, so maybe we can go to this. One of the questions is, why are the ATCs empty except for Belgium, Germany, and Germany, Belgium? So I think we just saw this before.
Yes, so far we've just mapped the Allegro borders because in the early stages we were receiving ATCs from them. So the remaining borders will be published and mapped really soon.
Yeah. Okay, so that will still come indeed. And that says also maybe for Steve, can with the use of constraints, so probably allocation and external constraints, TSOs adjust limit the flows calculated by the flow-based market coupling algorithm?
Can we limit the flows? Yes, absolutely. Yeah. So an allocation constraint is there to avoid a core hub to take an extreme net position. So let's say net position which is technically not deemed feasible by a TSO applying the allocation constraint. So it will, it can limit the market coupling outcome. And when it does that, we will see it in the KPIs later on as well. This is also visible.
Thanks. Syed, there are also some questions about CDBE, because in CDBE, of course, there is already an operational process with flow-based. And there are some questions about, will the CDBE data also be available in this publication tool?
Yes, that's correct. We will migrate all the CDBE data to the publication tool, indeed.
But it will be a separate publication tool then for CDBE or will it be in the exactly same tool?
It will be very similar in my opinion, yes. Yeah. We're going to migrate it and integrate it together to allow users to have all the data at one place.
Yeah. And the question is, will CDBE also available in this tool, so also after core flow-based go live? And then I think the answer is yes, at least for a certain period then.
Yes, that's correct.
Yeah. Okay, those were the questions at least that we received so far. So then I think we can go to Marius for the KPI reports.
Yes, good afternoon, everyone. So the second part of the transparency framework is basically our KPI reporting. which consists of mainly two things. So first of all, a monthly KPI report that we publish on JAO. And secondly, we have also an accompanying reading guide because the calculations and how to interpret certain KPIs are then described in this reading guide. So, of course, first of all, this obligation for core TSOs exists to continuously monitor the effects and the performance of the application of this methodology. And we are obliged to do this on a quarterly basis, but we said during the external parallel run, let's increase our frequency of developing these and sharing these reports with you. So we do it now on a monthly basis. And what is important to keep in mind as well is that these KPI reports are supposed to be complementary to all the data we already publish and that Steve and Sayed just showed you on the publication tool. So what we mainly do in these KPI reports is to show certain aggregations of data on a daily basis, per TSO basis, or over a whole month. And of course, the main idea is to get a feeling of what are the outcomes of the capacity calculation, what can be expected in terms of available capacities after the core go live, and also what can you as market participants then, of course, also expect as a market coupling outcome after go live. Here it is important to keep in mind that we use the simulation facility for doing these market coupling simulations. So we consider we take into account the currently existing order books for these market coupling simulations. So a typical KPI report consists of roughly 5 different categories, and the idea behind each kind of different KPI category is, of course, to provide data insights for you, but also each KPI attempts to provide answers to a certain set of questions. And what we have prepared for you today is kind of a small zoom in for a certain set of KPIs. And then afterwards, of course, we have this the Mentimeter and the Q&A session where you can also ask more detailed questions. So the first KPI we wanted to show you is 2 KPIs on the non-costly remedial action optimization, mainly because this is a recent introduction in June and May to the capacity calculation process, so rather fresh. What this KPI is supposed to give us an answer to is, okay, which remedial actions were actually used by the non-costly remedial action optimization and how often did it apply per TSO. So on the top of the graphs, you can see how often the PSTs of certain TSOs were used as a share of all hours when the NRAO ran. So here we can actually see quite some optimization for many TSOs. I see somewhere between 60% on average of the hours the PSTs are tapped to optimize the flow-based domain. On the bottom, you have a kind of share or an overview on topological remedial actions and how often these are used. A bit less so, but also because at this point in time there were also fewer topological remedial actions in the process. The relative RAM KPI is the idea there is, okay, how much did then, when the NRAO worked and optimized, how much did it increase the capacity and especially where? So on the blue graph is the relative RAM before NRAO, and the red graph is the column is the relative RAM after NRAO optimization. And here you can see that it, for some TSOs actually quite increasing capacities quite a lot. And but in general, if it works, it is increasing the capacity on the limiting network elements that were encountered by the NRAO. The latter is important to keep in mind because we see, for example, for Croatia, Hungary, or Romania, we don't see any application or RAM change. And this is mainly because then the NRAO did not encounter any limiting element from these kind of TSOs. So there's nothing to worry about there. The second category of KPIs is, we heard a lot already this morning and also this afternoon about adjustment to min-rams. We heard about LTA inclusion. So this set of KPIs is supposed to give us an idea of how much virtual capacity is actually added within the capacity calculation per TSO. So this is what you can see on the left side mainly. So it's an average per business day for each TSO for all the network elements for this specific business day. You also have it in the report. You also have it for top 20 network elements, but here it's done for each TSO. And here you can also see varying amounts. I think, Belgium stands here out, for example, with 870 megawatt on average as a maximum AMR plus Lta margin per business day. But most importantly is also, of course, not how much virtual capacity is added within the capacity calculation process, but also then how much is actually used by the market. And this is what you can see on the right side. So on the top, on the bottom, on the right side, you have the highest virtual margins at market balance for core TSOs as percentage. Over whole months here, July. And basically, if you can see no color, that means that just no virtual margin or virtual capacity was used for this TSO, for example, here on top for Slovakia. And the darker the colors or the darker the points, the less capacity in percent of Fmax was actually used. So it's very important to read these two KPIs, I would say, also together, because, for example, we saw on the left, high values for Belgium regarding this virtual capacity, but on the right, you see it actually quite at the bottom, usually very dark, only a few percents are used by the market. Then I think that's also a good transition to more market coupling related KPIs as well. So what we have, or what we show here is, we show the most limiting network elements, so the top 20 and allocation constraints for a larger period now, so for March until mid-August. So we aggregated this for you and for this presentation today and for this workshop today. And what such a table is supposed to give us answers to is, which network elements making up the flow-based domain were then in the end actually the ones limiting the market coupling. And you can see this in the first column, that's the network element name. And the second one gives you, and the second and third, so the distinct hours gives you an idea of how frequently this network element was limiting the market coupling. So if we exclude the Allegro virtual hubs, which unfortunately are still in the external parallel run shown here, but they are an HVDC capacity interconnector. So it basically only tells us how frequently the market used the full capacity of Allegro. But if we disregard the first two elements, then, for example, Vichy-Ensdorf, the interconnector there, was limiting the market coupling in 231 hours. I think there it is important to keep in mind that we looked over a whole longer period. So in total, 143 business days. So in total, 3,257 hours, where we excluded DFP hours. So this is roughly around 7% of the MTUs when this was network element was limiting. Then you can also have an idea about the extent of how much it was limiting by the maximum of the shadow price. The shadow price basically means how much social economic welfare would have been gained in Europe if there would have been one more megawatt of capacity on that network element. And then to get a bit more deeper analysis of, what was the statistics behind these elements, We also show the average RAM, remaining availability margin, and also the minimum and maximum when it was limiting. I think here it is also important to keep in mind that we do not here include the definition of margin available for cross-zonal trade, but here it's really only the RAM, because in the margin available for cross-zonal trade, there you would have also included unscheduled allocated flows. It is not here shown in the RAM column, and that is why you can also sometimes see, especially with the minimum RAM, sometimes going below 20%. And also, what we also show here is how much or how sensitive these network elements were to cross-zonal trade by the zone-to-zone PDDFs. And what we can actually quite see here through the whole table is that it were actually all elements that were highly sensitive and highly useful for or highly used by cross-zonal trade. Yeah, on the second table on the bottom, you can we have more information on allocation constraints. It was also mentioned by Steve already. Basically, the allocation constraint is sent to the market coupling to Euphemia as a separate flow. That's why we also have a separate table for this. And you can see at the moment there are two allocation constraints used. So the Polish export and import allocation constraint and the Belgium import constraint. And there we also have the numbers available, how often it was limiting, and also which were the average numbers and the maximum and the minimum of the megawatt value for this allocation constraint. Why it is empty here for the Belgian import allocation constraint is that it was simply not limiting the market in this time period, and that is also why this is an empty row at the moment. And the next KPIs are on prices. I already saw this morning, but also this afternoon it was reiterated that you are also here for price forecasting. So I hope I cannot forecast here, but I look in the past. And what we show here is on the top, the bidding zone prices as maximum, average, and minimum over the whole period. And yeah, you can already see by the average around 60 euros, that were still the times when the market was not as heated up as we currently see. So that's basically the average and for each bidding zone. And on the bottom, you have, or we show the price spread per bidding zone border. And I think that's also a very positive message that we can give here, because, for example, we see in 40% of the hours over this whole period a full price convergence at most of the borders. And even if we also include more the definition by ESA of near price convergence with below €1 price difference per megawatt, we can even see it that for most borders it's in 60% of the hours we have full price convergence or. And last but not least, we also made a comparison for you because, of course, most of you are probably aware that the interim market coupling project went live for business day 18th of June 2021. So what we also did was a price comparison between the core market coupling simulations that we see now, or that we're doing now, that we're publishing on JAO webpage, and to which prices you also have access. And we compared it with the real prices for the bidding zones, for the core bidding zones. So really the prices that you see in operations. For this comparison, we excluded ours with DFPs because we wanted to compare apples with apples. And what you can see in the table is that there's a price difference on average. So a minus negative number is basically means that the price in core market coupling simulations was smaller than in real operations. So for over 1,131 MTUs. We did this, and here we can see actually for some bidding zones quite some, I would say, price decreases if there would have been, or if there's core flow-based market coupling. especially for, I think, Slovenia and Croatia, I think benefiting, of course, from implicit allocation as well, but also bidding zones like Hungary and Romania, decrease still their prices, even with core flow-based market coupling allocation. Yeah. And what we then also, what you can see in the bullet points below is what we also did is, okay, to compare how much price convergence was there in the whole core area for during the hours for after ICP go live. And there we saw in real operations, it was around 15% of hours when it was price convergence. And in the full, so in our market coupling simulations, we actually saw that for the whole core area, we saw on average, we saw 23% of hours with full price convergence. And I think that is, for such a large area, quite a large number of price convergence here. Yeah, and that was my quick walkthrough through the KPIs that we have prepared for you today. But yeah, we can now also go to the Q&A, and I'm happy to receive more questions on the slides here, but also if you have something regarding the reports, feel free to shoot.
Yeah, Marius, we checked the questions, and there are not too many, but maybe one important. Where can the monthly KPI reports be accessed? And I think we can show this shortly, because it's in the same environment as the JAO website, of course. So we have there, we have the JAO publication tool. If you go to the project section, so you have here the JAO website and project section, then core flow is market coupling. And then you end up here, and then you have next to the core flow based data parallel run, you have the publication tool and the KPI reports. So then you end up at this web page, and below all the KPI reports that are available are published. And if you open this one, yeah, then you can open such a KPI report. Then another question, is the number of countries borders allowed to submit allocation constraints fixed, or can it change after go live? So Marius, it's not directly related to the KPI report.
But it's part of the day-ahead capacity calculation methodology, and there it's currently allowed for 3 borders, and of course it would need to be amended for further allocation constraints. So yeah. We will not see anything after core go live.
Yeah, so it's fixed indeed for those 3 that were already mentioned indeed. Okay, good. And then maybe if there are more questions, let's see. They're not popping up yet. There was at least the previous question on CDBE data. It has been clarified that the current CDBE utility tool, it's called, it's a little bit different from the publication tool. So there will be just a link to the CDBE page, you can say, and the core page, but the same tool will be reused. But the data will be, of course, separated. So if you go to the core page, you should only see core data. So that was a small clarification on one of the previous questions. Yeah, at the moment, I don't see any other questions popping up and coming in. So maybe we can continue to the
to the summary and the closing actually. So what did we do today in this flow-based market coupling workshop? Well, we did a try to really summarize it. Obviously, this is not representing what we've told, but the goal of the whole flow-based market coupling in core is to facilitate sustainable European energy market by making an optimal use of the network. That's basically it. So that's why we are doing it. And how are we doing it? With an optimization based on a secure system where we combine physics and market together to make the best use of the network also from the economical way. Then around the transparency of flow-based capacity calculation, Well, we try to provide you with all the relevant data to do your own analysis, to do this market analysis, to do this price forecasting. So there's information on input, on network data, on market data, especially on the JAO website. Coming to that, about transparency and where you can find information. Maybe it's good to mention the communication channels we have. So there is this core consultative group that has been established a few years ago already, where we keep in contact with the market, keep the market informed about proceedings, also do some explanations about new developments, and give backgrounds. And also, this is an opportunity to ask questions, really. Usually, NRAs and also Acer is in this meeting as well, so there can be also interaction with them. Then there is the core section of the ENTSO-E website. ENTSO-E has for every capacity calculation region a separate site or a separate page, I should say, where we keep track of all the documents that are developed in core, but also where we publish the information on the meetings we have. For instance, the consultative group, but also other information. So the recording of this meeting and the presentation of this meeting will also be published on that core page on the ENTSO-E website. And obviously, there's also the ENTSO-E newsletter where you can get information in a broader sense about capacity calculation regions. And then, very important, and also mentioned before, we have the Q&A forum on the JAO website, where you can actually ask specific technical questions to the project partners, but also you can find answers of questions that have already been asked. So maybe you don't even have to pose a question there. There's a lot of information available there, and there is the link also for that. Then we would like to do a short evaluation, Gert-Jan, on this workshop.
Yeah, definitely. So we can, you can go to the Menti. Indeed, it's now indeed shown again on the screen. Maybe in the meantime, because there were still 2 questions at the very last moment, were the prices of simulations performed with the real order books? The answer is yes, indeed. It is being used. So, of course, different capacities, but indeed real order books. And also, there was a question about overall social welfare effects, economic surplus. And I think that's one of the indicators. I think it's 11. So that should also be one of the indicators present. So if you go to the NRA KPI report, then you should be able to find this. So maybe we can hopefully go to the Menti. Indeed, so we already see different people that have inserted some answers. And now again, some more. So the question was, how satisfied are you with today's webinar? So let's wait for a little bit the responses. So luckily we see quite some things in the right part. Of course, we're also happy to learn from this experience and improve for the future. But good to know. Of course, feel free to finish your answer, and then in the meantime, I will go to the next one. I think an important one also for the future, but also in terms of what kind of information we should make at disposal. Did you miss any subject? So I guess a words cloud. No. Okay. Well, I'm happy with this answer as a first one. But of course, again, if there are
maybe with the background that we more or less planned a second workshop to go on live, to be there before go live. Maybe something on procedural sides of things about processes. So that that is something actually we are discussing at the moment. So if this would be relevant for you, please let us know.
So we see some information missing the static grip model. So I think Steve already mentioned that this is something that will be addressed in the core CG. So then some more information will be available. Drinks at the end, yeah, definitely. I can understand this one, maybe compared to the past. The 5 is maybe the 5 topics that people are missing. Happy to learn which topics, of course. Coordinated validation, indeed, it has, I think, been shortly addressed. On this one, it's actually something also foreseen for after go live. So they have before go live, its focus is really on individual coordination, but it's indeed foreseen after go live to have and develop and submit also a coordinated validation approach. So I can imagine that there are questions, but also difficult maybe to completely satisfy this one. Deeper explanation of GSK. I can imagine, of course, that now we touch upon a lot of topics on a maybe somewhat higher level. So I can imagine that people would expect some more details in the future. Price clearing algorithm. Good. As said, please feel free to finish them. One of the next questions: what topics should be addressed in a follow-up session? As said, of course, for us, interesting. The next session, Ruud already explained, is mainly focused on procedures. But, of course, happy to learn if there are topics that more breaks.
Okay, good point.
I can confirm this one indeed, especially in the afternoon. Yeah.
Yeah.
The dash is maybe something that should have been written, or that nothing is to be addressed in a follow-up session. Let's see if we get more responses. So maybe it's the time lag. Or maybe just a lot of topics that already were covered. So that's maybe that's the thing that KPIs again. Yeah. Okay.
Okay. Yeah.
As said, please. Feel free to finish this, because it can definitely help to shape futures. And then the final question: any other feedback towards the organizers, so more in a broad sense, if there's anything that we should have as a takeaway?
Well, the drinks, of course, but.
No.
Some time lag now, I suppose, but I think everybody is exhausted.
Well,
okay, let's finish it off. Could you put on? Yeah. So on behalf of the speakers of today and Gert-Jan and myself, thank you very much for listening in and very much for your attention. And we hope that you make flow-based market coupling a success. Thank you very much. Goodbye.
Thanks.